In the profound stillness of a moonless night, the sky becomes a gateway to infinity. Overhead, arcing across the vault of the sky, is a pale band of light, soft, milky, mysterious, stretching from horizon to horizon. This is the Milky Way, our home galaxy as seen from within, the combined glow of billions of distant suns. On a clear night, far from any city lights, it spills across the darkness in a broad swath, like a faint, glowing river of cloud, shimmering with ancient starlight. Under this galactic midnight sky, when the world is quiet and still, we gaze upward and feel the gentle pull of its wonder and mystery. For countless generations, humans have looked up at this silvery band of light and woven countless stories and legends about its nature. Long before modern cities lit up the night and drowned out the stars, the Milky Way was a prominent companion in the darkness, a guiding light in the sky. To our ancestors, that hazy arch of light was alive with meaning, imbued with myth and symbolism. In every culture, the Milky Way became part of their cosmic lore, a canvas on which they painted their hopes, fears, and wonder. One beautiful legend comes from ancient China. They envisioned the Milky Way as the Silver River, Tianhe, the heavenly river, flowing across the sky. According to the tale, this river separated two lovers, Jinu, a weaver girl who was the daughter of a goddess, and Niulang, a humble cowherd. Their love was forbidden, so the gods placed them on opposite sides of the celestial river as the stars Vega and Altair. Once each year, on the 7th night of the 7th lunar month, a miracle occurs. A flock of magpies takes pity on the lovers and forms a bridge with their wings, allowing the weaver and the cowherd to meet for just one night. This reunion is celebrated as Qixi in Chinese culture, and on that night the Silver River temporarily runs dry as the lovers embrace. For the rest of the year, the two stare across the sparkling band of the Milky Way, longing for each other. It's a poignant story of love and the stars, illustrating how deeply the night sky can influence human imagination. Far to the south in Africa, there is a very different creation story for the Milky Way. The San people of the Kalahari tell of a time when the night was moonless and utterly dark. A young girl, feeling lonely and wanting to visit friends in another camp, found she could not find her way under the black sky. So she gathered glowing embers from her fire in a clay pot. As she travelled, she flung the embers into the air above to illuminate the darkness. The embers caught among the stars, forming a swath of soft light to guide her. Thus, the Milky Way became known as the backbone of night, a pathway of faint glow holding up the sky and helping people find their way in the darkness. In this tale, the Milky Way is literally born from fire and human need, a bridge of cinders connecting distant places. And there are countless other interpretations. The Hindus called it the Akash Ganga, the river Ganges in the sky, imagining it as part of a celestial dolphin in their mythology. Some Native American tribes spoke of it as the path of spirits journeying to the next world. European folktales likened it to a spilled sack of grain across the sky, or the trail of a wandering animal. In Australia, some Aboriginal peoples see not the bright band itself, but the dark dust lanes within it as the shape of a great emu stretched across the sky, a celestial creature outlined by where the stars are missing. Different peoples, separated by oceans and centuries, all looked up and saw something familiar in that band of light. a river, a road, a bridge, or the milk of a goddess. Each story was a reflection of wonder, a human attempt to explain the gentle glow that spans the night. Though their interpretations varied, they all convey a shared truth. The Milky Way has always inspired awe and comfort, making the vast night feel a bit more like home. Throughout history, the Milky Way has also served as a guide. Travelers and sailors often used its position to navigate in the darkness. One can imagine a lone wanderer crossing a silent desert night centuries ago, the band of the Milky Way arcing over the dunes. To that traveller, the glowing river of stars pointed the way, a natural compass in the sky. Likewise, far out at sea, ancient Polynesian navigators knew the patterns of the stars by heart. They would gaze at the thick star clouds of the Milky Way rising and setting, using them along with other stars to guide their canoes across open ocean. In a world before GPS and electric lights, the heavens were a map, and the Milky Way was among its most prominent features. Even in modern times, stepping outside under a truly dark sky reconnects us with that timeless experience. When you see the Milky Way, you are seeing essentially the same sight that guided your ancestors ages ago, unchanged and reliable. There is something profoundly reassuring in that continuity. Yet the true nature of the Milky Way turned out to be even more wondrous than the old stories imagined. What our ancestors saw as a continuous milky glow is actually the combined light of uncountable stars. When the first telescopes were turned to this band of light, observers discovered it was not a cloud or mist at all, but a multitude of distant stars, packed so densely that their light blends together. In 1610, Galileo Galilei was among the first to realize this. Through his telescope, the Milky Way's haze resolved into countless faint stars, revealing that our night sky's misty river was made of suns beyond counting. In that moment, the Milky Way transformed from myth into a real physical place, a vast assemblage of stars in space. Today, we understand that the Milky Way is a galaxy, a sprawling city of stars in space, tens of thousands of light years across. In fact, it's our home galaxy, one among billions in the universe, but uniquely significant to us. From inside it, we see only a band of brightness, but if we could soar far above the galactic plane and look down from afar, we would behold a magnificent spiral design. Imagine drifting high above the Milky Way, suspended in the intergalactic night. Below us spreads a vast disk of stars, like a great whirlpool of light in a sea of darkness. 4 graceful spiral arms unwind from a bright central hub, swirling like a giant pinwheel. The galaxy's flat disk is dotted with luminous star clusters and threaded with dark ribbons of cosmic dust. At the core lies a concentrated bulge of starlight, a glowing central ball of countless old stars. If you could stand on a planet near the center of the galaxy, your night sky would be awash with starlight. So many stars crowded together that darkness would be scarce. The nearest stars would be only light months apart instead of light years, and their combined glow could even cast faint shadows at midnight. It would be a splendid, perpetual starry twilight, unlike anything we experience in our relatively quiet corner. Stretching around and above this bright disk is a faint halo of ancient stars and invisible matter, a spherical aura enveloping the spiral. The entire galaxy rotates slowly, turning like a colossal wheel. Our own sun, racing along at incredible speed, still takes roughly 250 million years to complete one circuit around the Milky Way, a single, galactic year. In that immense interval, continents shift and species arise and perish. In fact, the last time our solar system was at this spot in its orbit, dinosaurs were just emerging on Earth. Over its roughly 4.5 billion year lifetime, our Sun has only completed around 18 to 20 such trips around the galaxy. Altogether, the luminous disk, the glowing core, and the dark halo weave a majestic galactic tapestry, a great wheel of stars, with a bright heart and invisible arms outstretched into space. In this grand structure, hundreds of billions of suns orbit the galactic center, bound together by gravity in a cosmic dance that has lasted billions of years. Our Sun, along with its family of planets, resides in this galaxy as just one tiny inhabitant among the multitude. We live in a fairly quiet region, roughly halfway between the galactic center and the outer edge. Our stellar neighborhood is part of a minor spiral arm called the Orion Arm, also known as the Orion Spur, a lesser branch nestled between two larger arms, the Sagittarius and Perseus arms. If the galaxy were a vast city of stars, our Sun would be in a suburban district, far from the crowded downtown of the core, but not out in the distant countryside. Here in this local spiral spur, the stars are spaced comfortably far apart, and the night sky around us is relatively serene and dark. We orbit the galaxy's center at a distance of about 25,000 to 30,000 light-years, enjoying a grand view from our midway vantage point. From this position, when we look toward the constellation Sagittarius on a summer night, we peer inward toward the galactic center and see the Milky Way's glow at its brightest and widest. Turning the other way, toward Orion in the winter sky, we gaze outward along our spur toward the galaxy's edge, where the star clouds thin out. Surrounded by a sea of stars, our Sun sails along gently, one star among hundreds of billions, carried by the gravity of the Milky Way through the cosmos. The spiral arms themselves are dynamic, creative realms of the galaxy. They are like crowded stellar boulevards where stars are born and migrate. If we move in closer, leaving our panoramic view from above and diving into one of these luminous arms, we find stellar nurseries and clusters scattered amid the starry swirls. Within the spiral arms, immense cold clouds of gas and dust gather. These are the wombs of new stars. Over millions of years, gravity causes knots within these clouds to draw together. As a cloud core collapses inward, it grows denser and hotter until, suddenly, a new star ignites at its center. When the newborn star's fusion fire turns on, it pushes back the surrounding darkness and begins to shine. Often not just one star is born, but dozens or hundreds together, like a litter of celestial siblings. They light up the remaining gas around them from within, making it glow in beautiful colors. These glowing clouds are what we call nebulae, vast, diffuse patches of light marking places of starbirth. One famous example is the Orion Nebula, a stellar nursery about 1,300 light-years away, visible even to the naked eye as a faint smudge in Orion's sword. Through a telescope, this nebula reveals itself as a softly luminescent cloud of gas tinted rose and purple, cradling a cluster of hot newborn stars at its center. Inside the Orion Nebula, hundreds of young suns have recently ignited, their fierce light causing the surrounding gas to fluoresce. Pillars and wisps of darker dust weave through the glow, sculpted by stellar winds. Features so striking that astronomers poetically named them the Pillars of Creation. Indeed, within those pillar-like clouds, new stars are being formed at this very moment. Sometimes, after the gas disperses, the sibling stars remain together as a loose group called an open cluster. The Pleiades, also known as the Seven Sisters in the constellation Taurus, is one such cluster of young stars. Born together and still travelling as a family, their blue-white light reflecting off remnants of the dust from which they formed. All across our galaxy's spiral arms, similar nurseries abound. The Eagle Nebula, the Carina Nebula, and many others, each a cosmic cradle where the next generation of stars is coming to life. In these stellar nurseries, the Milky Way continually renews itself, forging fresh stars from the raw material of space and continuing a cycle that has been ongoing for eons. Stars born in these nurseries will live for millions or billions of years, each following a life story determined largely by its mass. The most massive stars, dozens of times heavier than our Sun, burn their fuel ferociously and shine with a brilliant blue-white light, but they live very short, tumultuous lives. After only a few million years, such a star exhausts the hydrogen in its core. No longer able to support itself, it undergoes a dramatic collapse and then a final catastrophic blast. It may explode as a supernova, erupting in a burst of light that can briefly outshine all the other stars in the galaxy. For a few weeks, the region around it is bathed in the radiance of 100 billion suns. Then the light fades, leaving behind the shattered remnants of the star's former self. The core of the star collapses to an extremely dense object, either a neutron star, a city-sized sphere of degenerate matter, or if the star was massive enough, a black hole. The star's outer layers are blown into space as an expanding cloud of gas and dust. This debris, enriched with heavy elements forged in the star's heart, mixes back into the galaxy's reservoirs of gas. In time, those ashes of the old star will become part of new nebulae, seeding future generations of stars. It's a dramatic death, but not an end. It's a transformation that enriches the Milky Way. In recorded history, humans have occasionally witnessed such stellar explosions with the naked eye. For example, in the year 1054 AD, observers in China and elsewhere noted a brilliant new star that appeared in the daytime sky for weeks. Unknown to them, they were witnessing the supernova death of a star in the constellation Taurus. The expanding wreckage of that explosion, known today as the Crab Nebula, can still be seen in telescopes as a ghostly cloud of filaments. Another supernova lit up the sky in 1604 in the constellation Ophiuchus, and was studied by the astronomer Johannes Kepler. These events are rare. On average, perhaps 1 or 2 supernovae occur in a galaxy like ours per century, so to see one is a once-in-a-lifetime event. But they remind us that the Milky Way is not static. It is active and ever-changing, even if its changes often unfold on timescales far beyond human lifespans. Less massive stars, like our Sun, lead steadier, longer lives, burning their fuel gently over billions of years. When a sun-like star finally nears the end of its life, it doesn't explode violently. Instead, it expands into a red giant, swelling to many times its original size. In the process, it sheds its outer layers into space, creating a gorgeous planetary nebula, a glowing shell of gas expanding away from the dying star. The star's core is left behind as a white dwarf, an extremely dense, hot ember about the size of Earth, which will cool and fade over many billions of years. This too returns material to the galaxy, but more softly than a supernova, enriching the surrounding space with elements like carbon and nitrogen that were formed in the star's interior. In this way, the Milky Way is like a living ecosystem of stars. The galaxy continuously recycles matter through successive generations of stars. Giant stars live fast and die young in brilliant supernovae, seeding space with new heavy elements. Smaller stars live longer, some for trillions of years, quietly glowing and eventually puffing off their outer layers to enrich the galaxy more subtly. Everything in the galaxy is part of a grand cycle. Clouds of gas collapse into stars, stars shine, then age and die. Their substance returns to the galactic medium to become part of new clouds. This stellar cycle has furnished our galaxy with all the elements needed for planets and life. Every atom of iron in our blood, calcium in our bones, oxygen in the air we breathe, all were forged in the nuclear heart of stars that lived and died long before the Earth formed. We truly are made of stardust, children of the galaxy in the most literal sense. The Milky Way is our parent in that way. It bred the stars that made the elements that make us. It's a humbling and profound connection. When we look up at the Milky Way, we are gazing at the greater body from which we came. Along with new stars, the galaxy also gives birth to planets. Around many newborn stars, disks of leftover gas and dust coalesce into rings and clumps, eventually forming planets, moons, asteroids, and comets. Our own solar system formed in this way about 4.6 billion years ago. The Sun ignited at the center of a rotating disk, and the remaining material gradually gathered into Earth and the other planets. This process is happening throughout the Milky Way. In fact, astronomers now believe that most stars in our galaxy have at least one planet. Over the last few decades, we have discovered thousands of exoplanets, planets beyond our solar system, orbiting other stars in the Milky Way. We find them by the faint wobbles of stars and tiny dips in starlight as planets pass in front of their suns. The diversity of these distant worlds is astonishing. Some are gas giants, even larger than Jupiter, that skim scorchingly close to their stars. Hot Jupiters with blazing atmospheres. Others are icy, dim planets, far from any warmth. We found rocky planets a bit larger than Earth, called super-Earths, and even planets orbiting twin suns. There are exoplanets with years that last only days, whirling near their stars, and others so distant from their suns that their skies are nearly dark. A handful of these exoplanets lie in the habitable zone of their stars, the band where temperatures could allow liquid water on a rocky planet's surface, which is a key ingredient for life as we know it. One notable system, TRAPPIST-1, has 7 Earth-sized planets, several of which orbit in that temperate zone where water, and thus life, might exist. Another world, Kepler 452b, has been called an Earth cousin, as it orbits in the habitable zone of a sun-like star. We do not yet know if any of these distant worlds harbour life, but their existence confirms that planetary systems like ours are common. There could be billions upon billions of planets in the Milky Way, an almost ungraspable variety of worlds. Under the light of alien suns there may be diverse landscapes, planet-wide oceans, red iron deserts, purple twilight skies with multiple moons. Some of those worlds might be lifeless, but others could be teeming with life forms beyond our imagination. The Milky Way, it turns out, is not only a city of stars, it is also an ocean of worlds. With so many worlds and so many stars, we naturally wonder, could there be other beings out there looking back at us? Our contemplation of the galaxy would be incomplete without considering the possibility of life and intelligence beyond Earth. With hundreds of billions of stars and countless planets, it seems almost inevitable that life has arisen elsewhere in the Milky Way. Perhaps on some distant planet orbiting a far-off sun, life took root as it did here. Over eons, simple organisms might evolve into complex ones, and on a few worlds, intelligence and civilizations could emerge. The notion is both exciting and humbling. Our galaxy might be home to myriad life forms, or we could be among the very few. So far, we haven't detected any clear signals or signs of alien civilizations. The stars around us remain silent to our listening devices. This puzzling quietness, where is everyone, is sometimes called the Fermi paradox. The galaxy is so ancient and vast that if life and intelligence were common, one might expect evidence of it by now. Yet we find none. It could be that intelligent life is exceedingly rare. Perhaps civilizations are fragile and short-lived, blinking out before they can reach out. Maybe they're there, but choosing to stay quiet or hidden. Or it might simply be that they're too far away, separated by gulfs of space and time that make communication difficult. And yet, when we look up at the Milky Way, it's tempting to imagine that somewhere, on a planet circling one of those countless stars, someone else is also gazing at this galaxy band and wondering about us. They might have their own myths for the Milky Way, their own science, their own questions about companions in the universe. Perhaps ancient civilizations rose and fell long ago in our galaxy, leaving behind ruins now cold and quiet on distant worlds. Perhaps a highly advanced culture long predated us and explored the galaxy eons ago, so that faint whispers of their actions, maybe some anomalous cosmic phenomena, are out there waiting to be recognized. These ideas sound like science fiction, yet they arise naturally from contemplating the sheer scale of the galaxy. Until we have evidence, we live with the question and the hope. We ourselves have begun reaching out into the void. Projects like SETI, the search for extraterrestrial intelligence, are listening for faint radio signals from distant stars, hoping to catch a greeting from another civilization. We sweep the skies with radio dishes and scan the starlight with sensitive instruments, looking for any sign that we are not alone. And we send out our own messages. In 1974, astronomers used the Arecibo radio telescope in Puerto Rico to beam a simple binary encoded greeting toward a distant star cluster. Essentially, a cosmic message in a bottle, tossed into the vast ocean of the galaxy in hopes that another intelligence might one day receive it. These efforts may be quixotic, but they carry our hope and curiosity outward. Through them, we whisper into the darkness, trusting that if the cosmic ocean has other sailors, one day we might make contact. The distances between stars, however, are enormous, presenting a formidable barrier to any direct interaction. Even our closest stellar neighbour, the Alpha Centauri system, about 4.3 light-years away, is unimaginably far. At the speed of current spacecraft, it would take tens of thousands of years to reach it. The Milky Way's scale truly defies ordinary experience. A beam of light, the fastest thing in existence, takes over 4 years to travel from Earth to the nearest star, and about 100,000 years to travel across the galaxy from one end to the other. For humans or other beings, traveling among the stars is a daunting challenge. It's no wonder we've so far sent only robotic emissaries even to nearby stars in our dreams. In reality, we have just 2 tiny probes, Voyager 1 and 2, that have barely left our solar system to enter interstellar space. They carry golden records with sounds and images of Earth, a brief greeting from our civilization, and they will drift among the stars for millions of years. These little spacecraft are humanity's opening notes in the great cosmic symphony, our way of saying, we were here and we wonder about you. Still, the idea of interstellar voyaging captivates us. In our imagination and fiction, we've conceived of ways to bridge the vast distances. Generation ships, where many generations live and die en route to a new star, or suspended animation, allowing travelers to sleep through millennia. Scientists have speculated about advanced propulsion, perhaps fusion rockets, solar sails pushed by laser beams, or even more exotic concepts like warp drives that bend space-time. At our current technological level, such things remain speculative. Yet the fact that we can imagine them is itself remarkable. It speaks to an innate restlessness, a desire to reach out and know what lies beyond the horizon, even if that horizon is the edge of our galaxy. One day, in the distant future, humanity, or whatever we become, may find a way to send crewed ships to the stars, turning points of light into actual destinations. Tied to these dreams is the tantalizing concept of wormholes, hypothetical tunnels through space-time that could connect two distant points in the galaxy like a shortcut. General relativity allows solutions that resemble wormholes, though it's unknown if nature permits them or if they could be kept stable for travel. Still, wormholes feature in our theories and stories as a way to cheat the cosmic distance barrier, a bridge through a higher dimension where you could step from one side of the galaxy to the other in moments. No evidence for real wormholes exists. They remain a fascinating idea. Scientists speculate that if wormholes did exist, they might be found near extreme objects like black holes, or created by advanced beings with technology far beyond ours. It's the stuff of imagination, yet it fires our minds. The thought of a hidden gateway in the Milky Way, a secret door through which one could leap across light years, is undeniably alluring. Whether or not such shortcuts will ever be found, they symbolize our longing to fully explore and connect the galactic realm. Even without fanciful wormholes or warp drives, we have a profound way to journey through the Milky Way, our curiosity and imagination. Through the eyes of our telescopes, we have traveled to the galaxy's center and out to its farthest rims. Through robotic spacecraft, we've begun to touch the space between the stars. And through our minds, we roam freely. Right now, simply by contemplating these things, we are on a voyage, sailing the Milky Way on a ship of thought. The Andromeda Galaxy, our immense sister spiral, is in fact faintly visible, even now on a dark, clear night, as a subtle smudge of light in the constellation Andromeda. A humble preview of the galactic neighbour destined to mingle with our own. Far in the future, around 4 billion years from now, our Milky Way and the Andromeda Galaxy will begin a grand collision and merger. Over the course of several billion years, the two huge star systems will dance around each other, drawing closer. Their spiral arms will tangle and distort. From afar, one could watch them morphing, tidal streams of stars flung out, perhaps a new shape forming as they interact. Despite the titanic scale, individual stars almost never collide because of the vast spaces between them. Instead, the galaxies will pass through each other, and the combined gravitational forces will rearrange their stars into a new configuration. After a long and stately interaction, the Milky Way and Andromeda will likely coalesce into a single, larger galaxy. Perhaps a giant, elliptical galaxy, lacking the delicate spiral structure we know now. For any beings alive in our solar system's vicinity at that distant time, and Earth itself may be long uninhabitable by then, the night sky would change spectacularly. During the merger's early stages, Andromeda would grow from a small blurry patch to a grand swirl visible overhead, magnitudes larger than our current moon. Later, as the galaxies properly merge, the familiar band of the Milky Way might give way to a more uniform glow across the sky, or an entirely different set of star patterns. It's a dramatic fate, but one so distant that it need not trouble us. Right now, our galaxy is relatively stable and graceful, sailing together with its small companion galaxies around the center of our local group of galaxies. The merging of galaxies is part of the ongoing cosmic evolution. The Milky Way itself was built from earlier mergers, and in the future, it will contribute to an even larger assemblage. This highlights an important perspective. Even galaxies have life cycles. They are born in the early universe, they grow and change through collisions, star formation, and star death, and they can merge and transform into new entities. The story of the Milky Way is one chapter in the ever-continuing story of the universe. As we marvel at the ongoing life of stars within the Milky Way, we can also step back and consider the galaxy's own life story. The Milky Way was born in the early ages of the universe, not long after the Big Bang. Astronomers estimate that it began forming over 13 billion years ago. In those primordial times, our galaxy likely started as several smaller protogalaxies, clumps of stars and gas drawn together by gravity. These building blocks merged over time, combining their stars to form a larger system. Piece by piece, the Milky Way grew, gathering up smaller neighbors, a process poetically called galactic cannibalism. Echoes of this tumultuous youth can still be seen today. Our galaxy's halo harbors ancient stars and globular clusters that date back to those early mergers. These globular clusters are spherical gatherings of tens of thousands to millions of very old stars bound together by gravity, orbiting outside the main disk like glittering lanterns. If you could stand on a planet inside one of these clusters, your night sky would be unbelievably rich with stars, hundreds of them blazing brighter than any star we see from Earth, all packed into a small patch of sky. It would be a truly celestial city of lights, a far cry from the relatively sparse stars around us. Streams of stars orbiting the galaxy in unusual trajectories are also thought to be remnants of long-ago collisions, the shredded remains of dwarf galaxies absorbed by our own. Throughout cosmic time, the Milky Way's disk took shape as gas settled into a rotating plane and new stars sparked to life within it. The central bulge grew densely populated with old, reddish stars, while the spiral arms continued to be populated with new, bluish stars. Roughly 10 billion years ago, a significant collision, astronomers suspect with a small galaxy they've nicknamed Gaia Enceladus, or the Gaia sausage, from the pattern it caused in stellar velocities, gave the Milky Way much of its halo of stars and helped form a thicker disk component. Countless interactions, big and small, have sculpted our galaxy over eons. Even today, the Milky Way is not alone. It's orbited by several dwarf companion galaxies. For example, the Small and Large Magellanic Clouds, visible from Earth's southern hemisphere, are satellite galaxies to the Milky Way that one day may be absorbed into our own. And beyond these companions, our galaxy itself is moving within the local group, bound in mutual orbit with Andromeda, as described. and together our local group orbits within the even larger Virgo cluster of galaxies. Thus, the Milky Way exists within a hierarchy of structures, each influencing the other over vast timescales. Now, having wandered through the Milky Way's mysteries, its formation, its structure, its stars and planets and possibilities, we return to the gentle darkness of a quiet night on Earth. Our journey brings us back full circle to the simple act of stargazing lying under the cosmic canopy. The band of the Milky Way still stretches above us, serene and glowing, just as it did for our ancestors. But perhaps now we see it with new eyes. We recognize that hazy arc as the combined light of billions of distant suns. We sense the depth behind its beauty, the towering nebulae, the clusters of stars, the unseen halo of matter, the central black hole, all the facets of our galaxy that together create that misty ribbon of light. As you breathe in the cool night air and gaze upward, you might feel a deeper connection to the sky. Our minds have traveled tens of thousands of light years tonight, though our bodies remain here on our small planet. In imagination, we've soared above the galactic disk, dived among newborn stars, and contemplated the far edges of our galactic home. The Milky Way, once merely a pale arch in the sky, now reveals itself as a vast and dynamic home in the cosmos. In this hushed moment of galactic midnight, allow yourself to simply float in that feeling of connection and awe. The same Milky Way that inspired tales of rivers and bridges now inspires scientific discovery and dreams of exploration. It arches overhead like a bridge between past and future, between the known and the unknown. Its light is gentle but persistent, a glittering whisper in the darkness, inviting you to ponder and to dream. Let the subtle glow of the Milky Way be a comfort to you. It is the diffuse, collective light of uncountable stars, many of them long gone, others yet to be born, all together illuminating the night on your behalf. In a universe so vast and ancient, here we find a sense of place and continuity. The galaxy watches over the night, as it has for ages untold, a constant presence above a changing world. There is something soothing in that constancy. The Milky Way glides overhead as you prepare to rest, like a cosmic river carrying time and memory across the sky. Feel the weight of your body gently pulling you toward the earth, even as your mind drifts upward toward the stars. Between these two gravities, you are suspended in perfect balance, safe and at peace. You are a child of the Milky Way, resting under your home galaxy's light, safe and at peace. Let each star above be a reassuring lullaby, each distant glow a reminder that you are part of something vast and beautiful. The night is deep and calm, and the stars trace their ancient paths. In their silent presence, your own worries grow small and distant. In this tranquil state, imagine yourself drifting among the stars themselves. All around you, stars twinkle in uncountable numbers. You drift past a glowing nebula, a billowing cloud of stardust painting the darkness with a faint blush of pink. You glide by a cluster of young suns that shimmer like a nest of blue fireflies in the distance. Here and there, a lonely comet trails a gauzy veil, and a distant supernova remnant forms a silent, ethereal cloud of memory. You feel no fear and no hurry, only wonder and serenity. Space is vast and mostly empty, but it cradles you gently as you move. Time itself seems to slow to the rhythm of your breathing. There is only the soft glow of starlight and the sensation of gliding onward. Perhaps you are afloat on that luminous river of the Milky Way, gently carried from one bend of the galaxy to another. There is no rush, no destination needed, only the eternal flow of starlight around you. The glittering arc of the Milky Way embraces the sky, and you ride its light as a voyager of dreams. The cosmic ocean is silent and safe tonight, and you sail it with a quiet heart. Take another slow, deep breath now, filling your lungs with the cool night air, and then exhale gently, letting any remaining tension flow out and away. Feel the calm of the night settle around you. Gradually, your breathing slows and your eyelids grow heavy as the final thoughts of the day fade into the starlit background. The Milky Way above continues to shimmer, a guardian arch across the sky. It whispers that you are not alone, that you belong to this vast cosmic family of stars and dust and possibilities. Knowing that the galaxy that made you is watching over you, all the little concerns of the day feel far away and insignificant beneath this cosmic canopy. In their place is a profound peace, a quiet understanding that in the grand scheme, all is well and you are exactly where you need to be. So, as you ease into sleep, carry with you the peace of this galactic midnight. May your dreams be filled with starry skies and gentle journeys through cosmic landscapes. The Milky Way will be there when you wake, still arching in silent splendor overhead. For now, you can let go. You are cradled by the earth beneath and the universe above, drifting in the endless night with the glow of a billion stars to guide you into deep and restful slumber. At the heart of our Milky Way galaxy lies a deep and abiding mystery. We drift now into the galactic center, where stars crowd closer together than anywhere else in the galaxy, and night never truly falls. Here, 26,000 light-years from Earth, an ancient giant resides in deep silence. It is Sagittarius A, the supermassive black hole anchoring the Milky Way. Invisible to our eyes, we know it by the way the stars dance around an empty darkness. Over millions of years, these stars have become its silent companions, orbiting relentlessly under its gravitational spell. In this cosmic nightfall at the center, we see them, brilliant stars looping and whirling as if choreographed in a celestial ballet. One star, in a daring elliptical orbit, swings so close to the void that it races at a significant fraction of the speed of light, completing a full circuit in scarcely a dozen years. In comparison, our Sun takes 200 million years to circle the galaxy's center. Yet this star pirouettes around the black hole in the span of a human childhood. At its closest approach, it hurtles through space at nearly 30,000 kilometers per second, almost 10% of light's speed. Then it slingshots back out toward the surrounding swarm of stars, only to be drawn in again by the unseen mass at the core. Watching this star, and others like it, we realize that something truly extraordinary lurks at the focal point of their orbits. In our mind's eye, we could speed up time to watch this ballet unfold. The innermost stars would streak around in elegant ellipses, completing orbit after orbit in quick succession, like fireflies drawn into a whirl around an invisible flame. Farther out, other stars circle more slowly, their paths weaving a grand celestial choreography, all directed by the gravity of the unseen center. Over centuries and millennia, each star traces a rosette in space, a testament to the profound pull anchoring them. It is a mesmerizing dance on a scale almost beyond comprehension. In comparison, our sun's motion is exceedingly slow and stately. This dramatic contrast highlights how powerful the influence at the core must be. Sagittarius itself remains hidden from direct view, shrouded by intervening clouds of cosmic dust and gas, and by the very nature of a black hole, which permits no light to escape. Thick swaths of interstellar dust form a nearly opaque curtain around the galactic center, absorbing visible light. It is as if the galaxy has drawn a veil over its central stage. Only light of longer wavelengths, infrared and radio, can slip through these dusty curtains. And with such special vision, astronomers have begun to unveil this hidden hub. Yet its presence is betrayed by the graceful motions of those stars, a cosmic waltz dictated by gravity. 4 million suns worth of mass is packed into a region of space, smaller than the orbit of Mercury around our sun. It's a mind-boggling concentration, a point of almost infinite density. We cannot see the black hole, but we can sense the deep gravitational well it creates, like a silent whirlpool in the fabric of space-time. As we drift closer in our imagination, we notice a gentle glow around the darkness. This is the faint radiance of gas and dust, heated to extreme temperatures as they spiral into the black hole's grasp. Most of the time, Sagittarius A is a quiet, patient guardian, sipping only meager wisps of matter that stray too near. But now and then, a larger meal comes along, perhaps a wandering cloud of gas, or an unlucky star that ventures too close. For a brief moment, the darkness erupts. X-ray and infrared telescopes on Earth detect flares as the black hole momentarily blazes with energy from infalling material. To our eyes, it would still appear as darkness, but instruments reveal these flickers, like the faint heartbeat of a sleeping giant stirring in its slumber. Surrounding the black hole is a dense cluster of stars, some of the most tightly bound in the entire galaxy. In this extreme environment, a year can pass in the blink of an eye for an orbiting star, and gravity stretches and warps light itself. If we could place ourselves near one of these fast-moving stars at perigee, the point of closest approach, we would witness strange effects. Starlight from the rest of the galaxy would shift and warp, blue shifting as we dive deep into the gravitational well, then red shifting and dimming as we climb back out. Time itself would seem to slow down under the black hole's influence, but to the star, obediently following its path, this distortion is just the normal course of its existence. Year after year, these stars trace their elongated loops, heedless of the brilliant trap they skirt. Occasionally, two stars may draw too near each other in this crowded neighborhood, and a close encounter can fling one star outward at tremendous speed. Some of the fastest stars ever observed in the galaxy, so-called hypervelocity stars, might have been ejected from the galactic center, banished to the outskirts of the Milky Way by gravitational interactions with the black hole or with other stars around it. Imagine a star, perhaps once a companion in a binary pair, that strayed into the black hole's vicinity. One star of the pair is captured or disrupted by the black hole, while its partner is violently flung away, sent sailing out of the galactic heart at millions of kilometers per hour. These exiled suns journey through the galaxy's less populated regions, carrying with them the tale of their dramatic escape from the center. Yet for all its power, Sagittarius A is relatively gentle as far as black holes go. In other galaxies, supermassive black holes announce themselves with quasars and mighty jets of energy blasting across intergalactic space. Our Milky Way's central black hole, in this epoch, slumbers in comparative quiet. The evidence suggests it has not had a major feeding frenzy for a very long time. Still, hints of a more tempestuous past linger. Towering above and below the galactic plane are enormous lobes of high-energy radiation known as the Fermi bubbles, ghostly echoes of an ancient feast. These massive bubbles, extending tens of thousands of light years on each side of the center, could be the remnants of a time when Sagittarius A devoured a large influx of gas, or even a small galaxy, expelling energy in great outflows. Though invisible to our eyes, these bubbles shine in gamma rays, a faint afterglow that tells of a period when the black hole was not so quiescent. For now, though, the scene at the galactic center is one of darkness and light entwined in equilibrium. We float in the midst of it, observing the inexplicable contrast of extreme violence and deep calm. All around, stars crowd by the thousands. Many are old and cool, reddish elders that have survived in this cosmic city for billions of years. Some are surprisingly young and hot, blue-white stars burning fiercely, a paradox in a region so close to a destructive black hole. Their very presence puzzles astronomers, who wonder how new stars could form under such disruptive tides. Perhaps these youthful stars were born from the collision and collapse of gas clouds that drifted into the central zone. Or maybe they formed farther out and migrated inward. Whatever their origin, they now add to the rich tapestry of light around the dark core, like bright embers swirling around a hearth. In this bustling central hub, distances between stars can be merely a fraction of a light year, incredibly close compared to the solitude our sun enjoys. We can envision the sky from a hypothetical planet orbiting a star near the galactic center. The night would be flooded with starlight from every direction, hundreds of times denser with stars than the view from Earth. The concept of night might lose its meaning there, for there would always be a glow from countless nearby suns. If one could look toward the blackness at the very center, they might see nothing but the absence of stars in a tiny patch, the black hole's shadow itself perhaps imperceptible without special instruments, but indicated by the eddying of light around an apparent void. Perhaps, in our meditative journey, we pause to consider what lies within that void, beyond the event horizon of Sagittarius A, that point of no return beyond which even light cannot escape. Space and time are warped beyond recognition. Anything that crosses that threshold vanishes from our universe's view, lost to our knowledge, assimilated into the black hole's mass. Some things we know. The event horizon for this black hole is only about 12 million kilometers in radius, unimaginably small on a galactic scale. And yet, within that boundary, all our notions of place and time falter. No signal, no information emerges to tell the tale of what transpires inside. It is a true cosmic mystery, a one-way door. In a sense, Sagittarius A is an ever-present reminder that even in the brightest of cosmic nurseries, or busiest of stellar cities, there are places of complete and utter night, where the usual rules of nature give way to the unknown. We might imagine what it would be like to skirt the edge of this abyss. Our journey stays safely distant, but suppose a traveller ventured closer. They would see the light of the universe distorted into a ring around the black hole, a phenomenon actually confirmed by humanity's observations. With radio telescopes spanning the Earth, we have captured a faint, glowing halo, the silhouette of the black hole's shadow against glowing gas, confirming the dark titan at the Milky Way's core. If we could move even closer, though still safely outside the point of no return, the visual distortions would become surreal. Light from stars far behind the black hole would bend around it, so that we could see the same star on either side of the darkness, smeared into a ring of light. The black hole would act like a lens, its intense gravity curving space itself and warping the view of the outside universe into a bright halo around its shadow. It is a spectacle no human eye has directly witnessed, but physics and simulations paint the picture for our imagination. It is humbling to realize that humans, with ingenuity and patience, have managed to unveil even a glimpse of this hidden king of the galactic center. The image we've obtained is subtle, a blurred donut of light, where photons orbit and some escape to be recorded, while inside the donut lies darkness where the light did not return. It is as if we have glimpsed the profile of a ghost, seen only by the light it blocks. With this insight, we linger in awe at Sagittarius A's domain. Here is the still, dark hub upon which our entire galaxy rotates. Every star we see in the sky, including our Sun, is destined to continue orbiting this central mass for eons to come. The black hole is like the quiet spindle on which the spiral of the Milky Way is wound, and around it, the stars dance tirelessly, generation after generation. Some will end their lives as supernovae, briefly adding to the brilliance of the region before fading into neutron stars or black hole remnants of their own. Those remnants may in time be drawn toward the center, joining the entourage of Sagittarius A. It is thought that dozens of smaller black holes, the corpses of massive stars long gone, lurk in the vicinity, slowly sinking toward the middle. Perhaps occasionally two of those small black holes will merge, sending out a ripple of gravitational waves, a silent ringing of space-time through the surrounding stars. All of this transpires over incomprehensible timescales, in a place that, to us, seems almost frozen in eternal night. We take a long, slow breath, absorbing the grandeur of the galactic center. In this realm, the boundary between reality and mystery blurs. We accept that some questions will remain unanswered, and that is part of the beauty. The central black hole stands as a profound enigma and a central pillar of our galaxy's structure. It is a force that binds, even as it can destroy, and it anchors the cosmic architecture around it. In the stillness of this moment, we find an odd serenity in knowing that such extremes exist. Gently, we begin to drift outward from the central glow and darkness, leaving behind Sagittarius A and its whirling stellar court. We move through the tightly packed central bulge of the galaxy. We steal one last glance toward the core. From here, the black hole itself is invisible, swallowed in the brilliance of the surrounding stars and dust. It's astonishing that something so concealed and small can govern the motions of this entire crowded hub. A silent conductor, it orchestrates the cosmic waltz we witnessed, yet remains unseen, a profound reminder of the unseen forces at work in the universe. The bulge around the center is a great spheroidal mass of stars. The stars here are predominantly old, their light tinted with ages. Golden and red hues dominate, the hallmark of suns that have long since consumed the prime of their hydrogen fuel and are evolving into giant phases, or quietly cooling on their way to becoming white dwarfs. This central bulge is like the glowing core of a lantern, densely populated and warm, with the accumulated light of billions of suns. Many of these stars formed when the galaxy was young, and they carry in their faint spectra the signatures of a primordial era. As we leave the crowded central bulge behind, we enter the vast expanse of the galactic disk. Unlike the spheroidal bulge, the disk is a broad, flat plane, the Milky Way's great wheel, stretching out around us. Here the stars are more spread out, and they often gather in sprawling spiral arms that wind gracefully from the center. We glide outward along one of these spiral arms, and the environment transforms before our eyes. Within the arm, new wonders appear. Luminous blue-white stars shine intensely, far younger and hotter than the ancient red stars of the bulge. They cluster in groups and associations, some only a few million years old, cosmic youngsters whose brilliance outshines their elders for the short time they burn. Around them, glowing nebulae spread like colourful ethereal clouds. We pass by a stellar nursery, an immense nebula of gas and dust illuminated from within by newborn suns. It might resemble the Orion Nebula, or the Trifid Nebula known from Earth's sky. Swirls of violet and rose and blue were our eyes sensitive to those colours, where energetic starlight excites the gas. Dark, pillar-like shapes jut within the cloud, where denser clumps shield parts of the nebula from the glare. In those pillars, new stars are quietly taking shape. This is a region of ongoing creation, the galaxy forging new stars even as old ones fade elsewhere. Not everything in the disk is so young, of course. Between the major arms lie interarm regions where star formation slows down. Here we find many middle-aged stars, like our Sun, and older ones as well, peacefully orbiting through a sparser sea of neighbours. Still, the spiral arms mark where the action has been in the recent past. As density waves, or perhaps the tidal influence of the galaxy's bar, sweep through, they compress gas and spark waves of starbirth, leaving a trail of bright, short-lived stars that make the arms stand out. In the wake of these waves, the massive stars live out their brief lives and often die in spectacular supernovae, enriching the surrounding gas with heavy elements that will one day form new generations of stars and planets. Drifting further along the arm, we come upon an open star cluster, a loose gathering of dozens or hundreds of stars that all form together. The cluster's stars twinkle like a small brood of siblings travelling together through the galaxy. They may be only a few 100 million years old, shining a bit more softly than the bluest newborns, but still youthful and radiant. We navigate gently through the cluster. The stars are spaced far enough apart to give each other room, but they share a common origin and move as a family through the disk. Over the next few 100 million years, gravitational forces will gradually disperse them, and this cluster will dissolve, its members blending into the general stellar population of the Milky Way. Our own Sun likely began in a similar cluster more than 4.5 billion years ago, alongside sister stars that have long since scattered across the galaxy. It's humbling to think that somewhere out there, far-flung in the Milky Way, those sibling stars of the Sun may still shine, strangers to us now, but born from the same cloud. Throughout the disk, We notice dark rifts cutting across the starlight, enormous clouds of interstellar dust that obscure the light of more distant stars behind them. These are the dark nebulae, sometimes seen from Earth as the Great Rift dividing the Milky Way's band in the sky. Up close, they are intricate and beautiful in their own subtle way. Cold, dense molecular clouds where starlight cannot penetrate. Within their lightless depths, embryonic stars are hidden, slowly gathering mass. We skirt the edge of one such cloud and feel the temperature drop in its shadow. It is tranquil and obscure here, a cocoon where in time new stars will kindle and push the darkness away. As we move farther out from the centre, the pattern of arms and gaps continues, though the overall density of stars and gas is slowly decreasing. We pass through the region of our solar system's neighbourhood, known as the Orion Spur, a minor spiral arm where our Sun resides. This is a quieter district between larger arms. Indeed, our Sun is in a relatively calm spot, not too near any massive star cluster or tumultuous nebula. Perhaps this benign environment was a blessing, providing a stable haven for life on Earth to develop over billions of years. In this suburban part of the galaxy, stars like the Sun drift in wide orbits, each mostly minding its own affairs. Looking toward the galactic center from here, one would see the inner arms and bulge as a milky glow in one direction. Looking the opposite way, out toward the edge of the galaxy, one finds the stars thinning out, with blackness beginning to dominate between the points of light. Continuing our journey outward, we traverse beyond the Sun's locale and pass the last coherent spiral arm. The stars grow fewer, the gas clouds more scattered. We are reaching the outskirts of the galactic disk. At these distances, tens of thousands of light years from the core, the grand design of the Milky Way tapers off. We might encounter a lone bright star here, or a sparse cluster there, but overall, the disk fades into the dark. Occasional stellar remnants, like isolated neutron stars or quiet black holes, may wander these parts unseen, traces of the galaxy stretched thin. Eventually, even those solitary beacons become rare. The plane of the galaxy, once teeming with light and colour nearer the centre, is now a faint silvery haze behind us. Finally, at around 50 or 60,000 light-years from the centre, we reach the outer rim of the Milky Way's stellar disk. For a moment, we linger at this threshold between the galaxy and the intergalactic dark. The emptiness beyond is vast and quiet, and behind us the sprawling pinwheel of the Milky Way glimmers in all its glory. Ahead of us lies a starless gulf, and behind us lies everything we've ever known. We take in the sight in silence, feeling both the deep solitude of space and the embrace of the starlight we've travelled through. Then, with a gentle sense of farewell, we begin to drift upward, leaving the flat disk behind. Now we gently lift above the plane of the galaxy and look around. Far below, the disk we traversed appears as a hazy band of light, thicker and brighter toward the centre we came from, thinning toward the edges. We see the spiral structure in its entirety from this vantage. The winding arms, the glowing central bulge, all embedded in a tenuous halo. This panorama is breathtaking and silent. The bustling activity of the spiral arms lies below us. Ahead, above and below, stretches the more ethereal realm of the galactic halo, extending in every direction around the Milky Way's disk. As we ascend into the halo, the stars become sparse, and the darkness deepens. We are moving not just outward in space, but backward in time. into regions that preserve the Milky Way's ancient history. Seen from here, the Milky Way truly resembles an ancient metropolis of stars. Its crowded core and vibrant spiral avenues lie beneath us, but surrounding that city of light is a vast hinterland of memory. The halo is like the great, calm sky above a busy town, where relics of the past quietly reside. In this halo, we find the fossils of the galaxy's youth, lone wandering stars, globular clusters of incredible age, and streams of stars that are the stretched remains of long-ago galactic mergers. This is the realm of galactic archaeology. Everywhere in the halo, if we search carefully, we find clues about how the Milky Way was assembled. Its old districts and newer additions, its monuments and ruins scattered throughout. We are now cosmic archaeologists, deciphering the history recorded in the motions and compositions of these remote stars. In the lower stellar density outside the bulge, we can pick out distinct populations of stars. Some stars, like our Sun, orbit within the flat plane of the galaxy's disk and tend to be comparatively younger, enriched with heavier elements forged by previous generations. But a different population is here as well, one that lifts our gaze above and below the plane. The halo of the galaxy, an almost spherical cloud of stars surrounding the disk, is composed mostly of ancient ones. These halo stars, along with the globular clusters they often reside in, are relics from the galaxy's youth, or from smaller proto-galaxies that merge to form the Milky Way. Their orbits are not confined to the neat rotation of the disk. Instead, they plunge in and out at various angles, tracing ellipses or looping paths far above the galaxy's luminous spiral arms. Imagine gliding alongside one of these halo stars. It may be a small, dim red dwarf, or perhaps a burnt-out cinder, like a white dwarf, quietly traversing a path that carries it high above the galactic plane. It orbits the galactic center in a path that takes it tens of thousands of light years out into the darkness, nearly leaving the visible confines of the Milky Way, before gravity pulls it back inward. As it ventures outward, the star finds itself increasingly alone, the surrounding space growing emptier. Yet it carries on, following a trajectory set in motion billions of years ago. Where did this lonely traveler come from? Its chemistry might hold a clue. Stars like this often bear only trace amounts of heavy elements like iron or calcium, elements common in younger stars like our Sun. In fact, some halo stars are almost pristine, containing a composition close to that of the early universe, mostly hydrogen and helium, with only the faintest whispers of heavier atoms. Such stars are ancient indeed, possibly born when the universe itself was only a few % of its current age. They shine with a steady but subdued light, like old embers glowing faintly after a long night. By studying the spectrum of their light, astronomers learn their secret. These stars were born in an era before many supernovae had seeded the cosmos with metals, the heavy elements. In their youth, perhaps 13 billion years ago or more, they took shape out of primordial gas. They are living fossils, carrying in their being the chemistry of a young cosmos. Not all these ancient halo stars may have been part of the original Milky Way. Some might have been born in smaller galaxies that later merged into the growing Milky Way. Through our archaeological eyes, we begin to see patterns. There are streams of stars, like faint, drawn-out gossamer threads, drifting through the halo. These stellar streams are remnants of dwarf galaxies and globular clusters that ventured too close and were pulled apart, their stars strung along their former orbits. We come across one such stream, a sparse river of stars flowing high above the galactic plane. Each star in it once belonged to a smaller galaxy that the Milky Way devoured long ago. Over time, our galaxy's gravity stretched that galaxy into a long ribbon wrapping around the halo. One well-known stream, originating from the Sagittarius dwarf galaxy, loops around our galaxy like a stellar current in a vast ocean. We imagine observing those stars. They drift together, moving along the same broad path, a ghostly remnant of their former home. There is something poignant about it. These stars are immigrants to the Milky Way, now indistinguishable from native stars, yet their collective motion betrays their shared origin. They carry with them a memory of that slow, tidal embrace, the Milky Way gently drawing in a smaller neighbour over billions of years, integrating its stars into our own, like streams merging into a larger river. And it's not only stars that are strewn about. An enormous stream of hydrogen gas, torn from our galactic neighbours, the Magellanic Clouds, wraps partway around the Milky Way as well. This Magellanic stream, invisible to human eyes but revealed by radio telescopes, is like a great tide of fuel slowly being added to our galaxy. In time, some of that gas may rain down onto the Milky Way's disk, sparking new stars and keeping our galaxy growing. All around the halo, similar stories abound. Dozens of such star streams have been found, each a trail of stars telling of a merger or accretion event in our galaxy's deep past. We pass through one stream and into another. Some are diffuse and ancient, their stars now widely dispersed and hard to distinguish from the general halo population. Others are relatively fresh, clearly delineated and coherent. They whisper of events perhaps only a few billion years ago, recent by the galaxy's standards. It is like walking through a museum of ancient civilizations, each stellar stream a collection of artifacts from a different fallen world that became part of ours. We encounter a grand structure of stars and pause to appreciate it. A globular cluster drifting serenely in the outskirts of the galaxy. Globular clusters are tight spherical collections of stars. Hundreds of thousands of stars packed into a ball only a few dozen light years across. They too are among the oldest things in the galaxy. The one before us might be as old as 12 billion years. Its stars are closely bound, swarming around a common centre of gravity, like bees around a hive. The cluster glows with a gentle, concentrated light, predominantly amber, for its stars are old and metal poor. This particular cluster has likely been orbiting the galaxy's centre since the Milky Way was young. Perhaps it formed as part of the nascent Milky Way, or perhaps it was the core of a dwarf galaxy long ago absorbed. Indeed, some globular clusters show hints in their star's chemistry that not all members formed at the same time, a clue that they might be the last remnant of a small galaxy, the rest of which was torn apart. As we float by the cluster, we note its spherical symmetry, a microcosm of a galaxy itself. If one could stand on a planet inside such a cluster, the night sky would be richly carpeted with thousands of stars, many times closer and brighter than those in Earth's sky. It would be a glorious, crowded firmament, perhaps almost too bright to find true night. From that hypothetical world, the Milky Way would appear as a majestic band in the distance, a glittering presence encircling the sky. Life in a globular cluster if it could survive the gravitational hustle and stellar radiation, would know a sky ablaze with near neighbours. And yet beyond the cluster's boundaries, the galaxy would shine as a distant beacon. We continue on, and now we begin to see that the halo, this extended sphere of old stars and globular clusters, is not chaotic, but has structure and stories encoded in it. With patient observation, one can piece together the motions of various groups of halo stars and discern the vestiges of ancient orbits. It's as though the galaxy's halo is a memory vault, where events from 10 or 12 billion years ago still leave their imprint in the positions and velocities of stars today. Astronomers have learned to decode some of these imprints. They speak of a great merger event early in the Milky Way's life, when a proto-Milky Way collided with a substantial galaxy in its youth. Evidence of that event can be found in an identifiable population of stars. These stars have orbits that carry them far out in the halo and then back in on radial paths, and their chemistry differs subtly from stars born in our galaxy's main disk. They are believed to be the remnants of that long-ago galaxy, sometimes nicknamed with colourful names in research, though here we simply recognise them as the stirrings of a cosmic past when the Milky Way was still assembling itself. We visualise that ancient collision not as a single violent crash, but as a prolonged intermingling. Over hundreds of millions of years, the two galaxies passed through each other, danced a gravitational duet, and eventually became one. The stars of the smaller galaxy, flung into wide, elongated orbits, gradually mixed into the Milky Way's halo. The result is still with us. Those stars are now part of the Milky Way, yet their presence can be discerned by those who know how to look. Contemplating this, we gain a sense of the Milky Way as something alive and evolving. It was not born whole. It was built piece by piece, star by star, galaxy by galaxy. And it continues to evolve even now. Our journey through the halo is a journey through time. Each ancient star, each stream, each cluster is like a chapter in a very old book. The writing is faint but legible to the careful reader. We feel almost like historians or archaeologists sifting through the darkness for clues. Every so often, we come across something that stands out, perhaps an unusually metal-poor star, so pristine it might be among the first generation born after the universe's initial stars. These are exceedingly rare, but they exist, twinkling faintly, almost forgotten in the vast sea of the sky. They remind us that the Milky Way's story is connected to the story of the universe itself. They are messengers from a time when galaxies were just beginning to form. Now, as we float farther from the galactic centre, nearing the edge of the visible Milky Way, the stars thin out nearly to nothing. We begin to sense that the grand structure of our galaxy is not limited to what our eyes can see or what the stars illuminate. The halo of the Milky Way extends far beyond the last lonely outposts of stars. And here we approach another mystery, perhaps the most profound of all when it comes to understanding galaxies: the mystery of dark matter. Even as our ship of the imagination leaves behind the last faint globular clusters and solitary ancient stars, the influence of the Milky Way continues to be felt much farther out. It is as though an invisible sphere surrounds the galaxy, a halo not of stars, but of something we cannot see, something that outweighs all the stars and gas we have observed. Dark matter. The very name is evocative. Matter that is dark, not in colour, but in its refusal to emit or reflect light. It neither shines nor casts a shadow. It does not glow or absorb. It simply is, known only by its gravity. As we drift into the dark outskirts, We notice nothing new with our eyes. And yet, if we could trace gravitational forces, we would find them still tugging at us, as if the galaxy has a much larger reach than the visible stars would suggest. In fact, the stars we saw earlier, orbiting in the far outer disk or halo, are moving faster than they should be if only visible matter existed. There must be additional mass, lots of it, hiding in the darkness. It's a gentle pull, but persistent and far-reaching. We sense the presence of this dark halo encasing the Milky Way like an invisible cocoon. What is it made of? No one knows for sure. Our narrative must accept that some chapters remain unsolved. Astronomers have pondered dark matter for decades, mapping its distribution indirectly by observing how stars and gas orbit at various distances from the center. They tell us that the dark matter halo likely extends well beyond the luminous boundary of the galaxy, perhaps 10 times the radius of the visible spiral. The total mass of this dark component could be 5 or more times greater than the mass of all the stars, gas, and dust in the Milky Way combined. In our mind's eye, we try to picture it. A vast spherical cloud or web of something transparent, overlapping the starlit galaxy and reaching far past it. Perhaps it has tendrils or clumps where it gathered smaller satellites. Just as we see star streams from shredded dwarf galaxies, we suspect there are dark matter clumps from those events too. To our limited senses on this dreamy voyage, dark matter is experienced only as a kind of silent, invisible presence. If we could release a test particle out here at the edge, we would find it being drawn gently back toward the galaxy, as if by a soft, unseen hand. This hidden mass binds our galaxy together, preventing the outer stars from drifting off into space. It is the scaffolding of the Milky Way, the framework that holds the shining tapestry in place. Without it, the galaxy would not be as it is. It might not have formed such majestic spirals or grown so large. In fact, dark matter was likely the foundation for our galaxy's birth. Eons ago, it began to clump under its own gravity, and ordinary matter, gas, followed, cooling and collecting at the centers of those clumps to form the first stars and proto-galaxies. In the stillness of intergalactic night, we think about how remarkable it is that something so important can be so unseeable. We, and everything familiar, from stars and planets to people and dust, are made of ordinary matter that interacts with light. But dark matter is different, an elusive substance, or perhaps a family of substances that interacts mainly through gravity. It's as if the universe has a secret structure, a vast shadow framework known only by its influence on the things we can see. The Milky Way's dark halo might contain countless clumps or particles for every star that shines, or it might be composed of exotic elementary particles born in the universe's earliest moments, now drifting through us as though we weren't even here. Indeed, billions of dark matter particles may be passing through your body each second without a trace, even as you lie here listening to the story of the galaxy, completely oblivious to their passage. They leave no mark and make no sound. Only in aggregate do they reveal themselves, holding the galaxies in their gravitational embrace. Though dark matter pervades the cosmos, it still eludes our full understanding. We have given it a name, but not yet uncovered its identity. So even here in our home galaxy, we are faced with an enigma, a reminder that amid all the starlight and knowledge we have gained, there remain unseen forces holding sway. There is something poetic in this. The Milky Way retains some of its secrets, inviting us to marvel and to continue seeking answers, even as we find comfort in its familiar glow. As we muse on these ideas, our journey has carried us to a truly remote place, the very edge of our galaxy's realm. If we turn around and look back now, what do we see? The galaxy in its entirety, perhaps. In our mind's vision, we have floated some 200,000 light-years out, far enough that the grand spiral structure of the Milky Way comes into full view. We see the flat disk with its graceful arms encircling the bright central bulge. We sense the faint sprinkling of globular clusters and stray stars in the halo around it. Beyond that, we know there is this massive, unseen halo of dark matter extending farther still. But by definition, we cannot see that halo, only infer it. In this panorama, our entire galaxy looks like a whirl of stardust and nebulae, a glittering pinwheel isolated in a vast, dark void. It is awe-inspiring and humbling to witness our home from such a vantage point. The stars in that pinwheel are many, roughly a few 100 billion in number. Yet even that immense tally of suns is outweighed by the dark matter halo enveloping them. It is as though the visible Milky Way is just the tip of an iceberg, the brilliant surface of a deep ocean of something we cannot directly behold. Still, the surface is beautiful and inviting, and it is all we directly know. As we face this cosmic ocean, we feel the depth of the unknown pressing gently around us. It is not an unsettling feeling, but rather like standing by a calm, dark sea at night, hearing only the distant whisper of waves and knowing the water stretches far beyond the horizon into unseen depths. The darkness holds secrets, but also cradles us. In the space around our galaxy, suffused in dark matter, there are also other things drifting. Wisps of hot, tenuous gas form an extended atmosphere around the Milky Way, and perhaps even a few stray stars have been flung completely free, now wandering the intergalactic night. They are like castaways, a star here or there, ejected by gravitational interactions, destined to roam the emptiness between galaxies. These lonely suns carry with them the legacy of our galaxy, even into exile. Tiny points of light adrift in nearly perfect darkness. The immensity of what surrounds the Milky Way is sobering. We feel truly in the middle of nowhere, suspended between galaxies. But even here, the influence of our galaxy persists in that invisible, all-encompassing halo. Eventually, farther out, even that gravitational influence will wane. At perhaps 1 million or more light-years from the centre, the dark matter halo peters out into the general background of the universe. We have come to the edge of what is Milky Way and what is simply intergalactic space. And yet, we are not completely alone, even here. In the distance, faintly, other islands of light glimmer. The Andromeda Galaxy, the Triangulum Galaxy, and numerous dwarf satellites of our Milky Way. They are separated from us by vast gulfs, but on this scale, within our local group of galaxies, they are still our neighbours. In fact, in the grand dance of the universe, they are partners with the Milky Way, bound by gravity, destined to interact in the future. Before we venture to the future, let us reflect on the entirety of what we've seen. We have traced the Milky Way's mysteries, journeying from the glowing galactic core to the faint halo. We marveled at the whirling stars around a hidden black hole at the center. We drifted through spiral arms full of newborn suns and misty nebulae. We listened to the silence of the halo, home to ancient stars and ghostly stellar streams from long-ago galaxies. We sensed the gentle tug of invisible dark matter and the soft breath of magnetic fields and cosmic rays. We contemplated the future collision with Andromeda, and we imagined humanity's steps among the stars. And now it's time to turn our thoughts to the future. In reflecting on everything we've observed, one could fancifully imagine the Milky Way as a living cosmic organism. Its core, with the beating presence of the black hole and surrounding old stars, is like a heart sustaining the system. Its spiral arms are the galaxy's limbs, stretching out and rotating gracefully, active with star birth, like blood carrying nourishment through a body. The invisible dark matter halo is a skeletal framework, giving shape and support, while the magnetic fields and cosmic rays are a subtle nervous system, carrying energy and whispering information across vast distances. Of course, the galaxy is not literally alive, but this metaphor highlights how beautifully the components work together. The Milky Way grows, changes, and maintains itself in a balance of forces and cycles, almost as if it has its own slow heartbeat echoing through the ages. Nothing in the cosmos is truly permanent, not even the great spiral of the Milky Way. And so we envision what fate awaits our galaxy in the eons to come. Far ahead, billions of years from now, an inevitable meeting is predicted between the Milky Way and our large companion, the Andromeda Galaxy. At this moment, Andromeda is a majestic spiral galaxy, a little larger than our own, residing about 2.5 million light-years away. To the unaided eye from a dark site on Earth, it appears as a faint smudge of light in the constellation Andromeda. But in billions of years, that faint smudge will grow ever larger as our galaxies draw toward each other, pulled inexorably by their mutual gravity. Andromeda is on a slow collision course with us, moving at hundreds of kilometers per second, fast by human standards, but languid on the scale of galactic distances. It will take around 4 billion years for the two to converge. We picture the scene in our minds, in the far future night sky as seen from Earth. If Earth still exists and has observers at that time, Andromeda has become a great approaching spiral, its hazy form spreading across the heavens. Over millions of years, it looms ever larger until its stars and our stars begin to intermingle at the edges. The disks of the two galaxies start to collide and pass through each other. It will be a collision in name, but not in the sudden, catastrophic sense. Instead, it will be a slow dance of stars and space, unfolding over so many millions of years that no single human observer would perceive dramatic change. Generations of future beings might live and die under an only gradually transforming night sky. Only by looking back over many millennia would the alteration be obvious, as Andromeda's dim glow grows into a majestic whirl of stars overhead. Such is the stately rhythm of cosmic events, imperceptible in the short term, yet awe-inspiring when seen from afar. When the Milky Way and Andromeda finally meet, it won't be a single quick crash and then done. The galaxies will likely pass through one another, then slow down, drawn back together by gravity, and oscillate before eventually coalescing. Their shapes will be dramatically distorted. Tidal forces will draw out enormous streamers of stars from each galaxy, tossing some stars into long tails stretching outward. But remember, even a galactic collision is mostly empty space meeting empty space. The likelihood of individual stars colliding is extremely low, because the distances between stars are so great. So while gravity will drastically alter the galaxy's shapes, the stars themselves will mostly sail past one another. To any inhabitants of star systems during that epoch, there may be no sense of violent crash, just a slow, majestic change in the night sky over many generations. Clouds of gas, however, will slam into each other, and that is where a spectacular transformation truly begins. As gas clouds collide and compress, they will trigger prodigious bursts of star formation. The night skies in those times, again, from some vantage point within the collision, might be ablaze with new, hot stars forming in brilliant clusters. Colossal stellar nurseries lit up by the ultraviolet glow of massive newborn suns. These clusters will rapidly burn, and within a few million years, the most massive stars will die as supernovae, adding more spectacle to the cosmic scene. It will be a time of intensified cosmic fireworks. Multiple supernovae might wink on and off like distant lightning in the merged galaxies. Future skywatchers, if any, could see bright new stars appear for a few weeks or months, the supernovae, where none were before, then fade away, while whole new clusters of young stars paint the collision night with a blue-white tint. The supermassive black holes of the two galaxies will begin a slow dance of their own at the center of this cosmic embrace. As the galaxies coalesce, these dark giants will sink toward each other, eventually orbiting one another and spiraling inward. In time, perhaps millions of years after the first close pass, they too will merge. When that happens, it will unleash an enormous burst of energy in the form of gravitational waves, ripples in space-time that will wash through the universe like the ringing of a great cosmic bell. No one will hear it in the conventional sense, but if there are advanced beings or sensitive instruments in that distant future, they would detect the subtle stretching and squeezing of space from that event. The merged black hole will settle at the core of the new combined galaxy, larger than either original. We can imagine the entire collision playing out over billions of years. The initial approach begins around 4 billion years from now, but the final merger won't be complete until maybe 6 or 7 billion years in the future. After 1 or 2 passes and a series of gravitational dances, the Milky Way and Andromeda will eventually become a single entity. The neat spiral structures we once knew will likely be gone, transformed into a giant elliptical or lenticular galaxy. A vast, rounded swarm of stars with no distinct arms, just an enormous, diffuse glow. Some astronomers have nicknamed this future galaxy Milkomeda, blending the names of Milky Way and Andromeda. The third large member of our local group, the Triangulum Galaxy M33, may join this cosmic merger as well. It could be captured by the combined Milky Way-Andromeda system, merging into the new galaxy at a later stage, and contributing its stars to the collective island of light. In the aftermath of such a titanic event, the new galaxy will eventually settle into a quieter existence. Initially, after the merger, it may shine more brightly due to the flurry of new stars, but over time, the excess gas will be used up or blown out, and star formation will subside. The resulting galaxy will likely be dominated by older, reddish stars. It may resemble the giant elliptical galaxies we see in galaxy clusters, a colossal, amorphous cloud of stars with a bright core and a large, extended halo of stars around it. The once beautiful spiral patterns will be a thing of the past, but the merged galaxy will carry on, slowly aging. Even after that, our galaxy's story isn't completely over. Eventually, our entire local group of galaxies, by then largely merged into one combined system, will be gravitationally alone. The expansion of the universe will, by that far future time, drive more distant galaxies away from us at such speeds that they slip beyond our observable horizon. At some inconceivably distant epoch, observers within the merged local group, if any exist, might see no other galaxies in the sky at all. Trillions of years hence, star formation will have long ceased. The remaining stars will burn out one by one, turning into white dwarfs, neutron stars, or black holes. The galaxy, or what remains of it, will gradually fade into a sea of dark remnants. But that twilight of the galaxy is in the far, far future, almost an eternity from our perspective. Let us not venture too far into that cold and silent future. It lies well beyond the span of any present imagination or concern. Instead, let's gently return to a nearer time and a more immediate dream. The dreams of humans and our own future within this galaxy. We live at a unique moment. We are creatures who can understand some of these grand cosmic processes, yet we have experienced only our very small corner of the Milky Way. But perhaps one day, we won't just imagine. Perhaps one day, we will venture out for real, further into the galaxy that gave us life. Picture the coming centuries or millennia, if humanity endures and continues to progress. With time, we learn to travel between the stars, slowly at first, perhaps aboard generational ships, crossing the interstellar void over centuries, or with advanced propulsion that shortens the journey. The idea of journeying to even the nearest star, Alpha Centauri, about 4 light-years away, is daunting to us now. But suppose one day we manage it. Suppose we begin to spread outward, establishing outposts around other suns, gradually extending our reach through the spiral arm. A person standing on a planet orbiting another star, perhaps a world in the Alpha Centauri system, or much farther, would look back at the star that is our sun and see it as just one more pinpoint of light among many. From that new vantage, the Milky Way's band might appear slightly different. Perhaps they would be closer to the center, or high above the galactic plane, subtly changing the view of the starry river across the sky. Yet, it would still be the same Milky Way, a familiar river of starlight uniting their sky with that of Earth and of all other colonies, a constant cosmic reminder of home. As humanity, or our successor species or machines, spreads, we would come to inhabit more perspectives of our galaxy. Over millennia, it's conceivable that we could send probes or even crewed missions to explore the spiral arms, to study up close the wonders we have so far only glimpsed from afar, to skim the event horizon of the central black hole, to visit clusters on the galaxy's outskirts, or to watch the Andromeda galaxy's approach from a closer viewpoint. Perhaps one day, far in the future, our descendants will navigate this cosmic ocean with ease. They might travel near the speed of light, hopping from star to star, or master technologies we can barely dream of, warp drives or wormholes that could shorten distances. For them, a tour of the galaxy's wonders might become a reality. Flying to the galactic center to witness the warping of space up close, or journeying to the far side of the Milky Way to gaze back at our entire galaxy from an external perch. We might even imagine them venturing beyond our galaxy altogether, becoming intrepid explorers of intergalactic space, looking back at the Milky Way as a whole, a pale disk of light suspended in darkness. Even if human beings themselves never travel so far, we have already begun sending emissaries. We have launched machines like the Voyager probes, which have now slipped into the space between the stars. They carry with them golden records containing sounds and images of Earth, a friendly greeting from humanity to whatever may find them in the far future. It will be tens of thousands of years before they might pass near another star, if they ever do. For now, they drift silently in the darkness, tiny ambassadors of Earth, with the Milky Way as their new ocean. They carry our hope that perhaps we are not alone, that someday these tokens will be found by other beings in the galaxy. After all, if life arose here on Earth, why not elsewhere among the countless planets orbiting those billions of stars? It's tantalizing to imagine that on some distant world, under the glow of the same Milky Way, other intelligences might be gazing up and wondering about neighbors in the cosmos. Maybe they too have dreams of reaching out beyond their sky. One day, far in the future, our descendants may exchange signals or even visits with such alien explorers, bridging the light years between stellar communities. For now, this remains a hopeful dream. But even the mere possibility adds a gentle sense of kinship to our journey, the thought that we share this vast galaxy with unknown friends, all of us under the same blanket of stars. Right now, without leaving our planet, we explore by the power of our minds and our ingenious instruments. We have mapped our galaxy's structure, charted the orbits of stars, and even measured the gentle ripples of space-time from far-off cosmic events. We gaze at the Milky Way with telescopes that reveal its wonders hidden in every band of light, from radio waves tracing cold hydrogen clouds, to infrared catching the glow of dust, to visible light showing the myriad stars, and X-rays unveiling high-energy phenomena. Through these tools, we roam the galaxy remotely, learning and imagining, preparing ourselves for the days when we might go in person. Even if we never physically venture beyond our solar system in large numbers, the Milky Way will remain our beautiful island home in the cosmos. It is an island, yes, but a vast and richly varied one. Knowing what we know now, when we step outside on a clear night and gaze up, the sight of that milky band stretching overhead carries so much more meaning. We understand that we are looking at the combined light of billions of distant suns, the glow of nebulae and clusters all woven together. We sense that beyond the darkness between those stars lies even more, the dark matter halo cradling us, the magnetic whispers and cosmic ray journeys happening unseen. When we look up from Earth, we are connected to all of it. For countless generations, people gazing at this hazy arch of light have woven it into their stories. The ancient Greeks imagined it as milk spilled by a goddess, hence calling it the Milky Way. In parts of East Asia, it was the Silver River, a celestial bridge. In other cultures, it was seen as the path of souls or the backbone of night. Though interpretations differed, all agreed it was something sacred and awe-inspiring. Today, with science, we have uncovered many of its secrets, yet the magic remains. On a dark night, away from city lights, that milky band still evokes wonder as it did for our ancestors. Every human being who has ever lived, every creature that has ever looked up at the night, has been bound to this galaxy and comforted by its light. We are made of its material, the calcium in our bones, the iron in our blood, the oxygen we breathe were all forged in stars of the Milky Way that lived and died long before our sun was born. We truly are children of the galaxy, both in a physical sense and a spiritual one. Knowing this connects us deeply to the Milky Way. When we gaze up on a clear night and see that silvery band stretching overhead, we are looking at our extended home across space and time. We travelled from the galactic centre with its roiling heart, out through the spiral arms and into the halo and beyond, all by following that river of light. Now our long journey through galactic midnight is drawing to a close. We have traced the Milky Way's wonders, journeyed through its secrets, and now it's time to simply be, to let all we've witnessed settle gently in our minds. Feel the gentle pull of Earth holding you, steady and secure after this cosmic voyage. Your body sinks deeper into comfort, and your breathing becomes slow and calm. Inhale the cool, starlit air and imagine it filled with tranquility. Exhale and release any lingering tension into the night. There is nothing you need to do now, but drift as the stars drift, unhurried and free. The cosmos is quiet around you, and you are quietly part of it. Let the vastness of the universe comfort you. Under the eternal canopy of the Milky Way, you are cherished and at peace. Close your eyes when you're ready, and let the darkness wrap around you like a soft blanket of starlight. In this calm, expansive darkness, you are safe. You are home. Sleep gently overtakes you, just as softly as the light of a distant star travelling through the vastness to grace your eyes. The midnight of the galaxy is deep and silent. A tranquil darkness sprinkled with the soft radiance of countless stars. In this peaceful cosmic night, we continue our slow journey through the Milky Way, drifting further into its mysteries. All around us, starlight glimmers like distant candles, and enormous nebula loom in the void, faintly glowing with ethereal colours. The galaxy feels hushed at this hour, an ancient living thing at rest, breathing slowly through its billions of suns. Far ahead, a delicate haze of light appears against the darkness, a nebula, the birthplace of stars. We gently float toward it, drawn by a subtle luminescence. This nebula is a vast cloud of gas and dust, drifting in the galactic disk like a cosmic cloud in the night. Up close, it spans many light years, towering like immense, shadowy mountains in space. Its edges are sculpted into wisps and filaments by long-ago stellar winds and ancient supernova shockwaves. Within its deep interior, new stars are being born. We drift into the heart of this stellar nursery. Inside, it is cool and dark. The gas here is mostly hydrogen, and tiny dust grains float like fine smoke. From a distance, the nebula glows softly where newborn stars at its periphery light it up, but here in the depths, only darkness and the faintest hint of far-off starlight rain. Yet there is gentle activity in this darkness. Invisible hands, the force of gravity, are at work, ever so slowly drawing denser clumps of gas inward. We sense pockets of the cloud where gas is gathering, growing thicker and heavier. These are the cradles of future stars. In one such dense core of the nebula, the gas has condensed enough that it begins to fall in on itself, forming a protostar. We imagine peering into that core, the gas is collapsing under its own weight. As it does, it heats up in the center. Thousands of years pass in the blink of a cosmic eye. The core grows hotter and denser, a sphere of gas hidden in a cocoon of dust. Eventually, conditions at the core become extreme, tens of millions of degrees, and then, quietly, a new star ignites. It is not an explosion, but a gentle kindling of nuclear fire. Hydrogen atoms begin to fuse into helium in the protostar's core, releasing energy. The inward collapse is halted by the outward pressure of this newborn star's light. The star is born. A tiny sun now shines where there was darkness. At first, it is still swaddled in its dusty cocoon, its light muffled. But its warmth begins to leak out, illuminating the surrounding nebula from within. Like a candle glowing inside a paper lantern, the young star makes the nebula around it blush and shine. Slowly, radiation and stellar winds from the newborn star push away the nearby material. The cocoon parts, and the young star emerges, casting off its veil. It lights up the nebula in radiant colours. We see hues of soft pink and red, the glow of hydrogen gas excited by the star's energy, and touches of blue where dust reflects the starlight. The nebula becomes a luminous cloudscape, curtains and pillars of gas sculpted by light and wind, billowing gently in space. It is a serene yet awe-inspiring scene, like sunrise glistening through misty mountains, but on a cosmic scale. Stars are often born not alone, but in groups. In this stellar nursery, many stars are taking shape together, like a cluster of cosmic siblings. Some are small, modest stars that will shine gently for a long time. Others are massive and hot, destined to blaze fiercely, but live brief lives. Perhaps we notice a particularly bright patch nearby. Another newborn star, much more massive than the first, is coming to life there. It glows blue-white with intense heat, already far brighter than our smaller sun-like star. This massive infant will burn its nuclear fuel quickly, living fast and dying young in only a few million years. For now, though, all the newborn stars are just beginning their lives, huddled in their nursery. Imagine dozens of infant suns embedded in the nebula, like a nest of fireflies in a fog. They are still surrounded by wisps of the cloud that bore them, and their collective light makes the whole nebula gently radiant. Some newborn stars have cleared space around themselves and shine boldly. Others remain wrapped in dusty blankets, detectable only by the warmth they emit. Over millions of years, this cluster of stars will gradually disperse as each star drifts on its own path. But they will always share a family bond from their common origin. Such scenes have even been captured by human eyes through telescopes. One famous stellar nursery, the Eagle Nebula, reveals towering structures known as the Pillars of Creation, great columns of dark cosmic dust and gas, light years tall, silhouetted against a luminous backdrop of newborn stars. Within those pillars, at their craggy tips, young stars hide, their light carving the edges into fantastical shapes. Another example is the Orion Nebula, a vast glowing cloud about 1,300 light-years from Earth, visible even to the naked eye as a faint patch in Orion's sword. Through a telescope, it blossoms into a swirl of rose and greenish light, with hundreds of baby stars clustered at its heart. These breathtaking vistas, captured in photographs, remind us that the birth of stars is not just theory, but a vivid reality. Cosmic cloudscapes of creation that truly exist throughout our galaxy. Drifting through this glowing nebula, we feel the gentle energy of creation at work. There is a hush, as though we are in a sacred nursery witnessing the first breaths of stars. The turbulence that once shook these clouds, perhaps from a previous generation of stars exploding, has settled here into a quiet incubator. Tiny grains of dust in disks around some newborn stars are beginning the slow process of building planets. The chemical elements here include not just primordial hydrogen and helium, but also carbon, oxygen, and others, seeds of future worlds, forged in earlier generations of stars, and now woven into new suns and their nascent solar systems. Around one of these emerging stars, a thin disk of leftover dust and gas circles, the makings of a planetary system. Inside that disk, minute motes of dust begin to stick together. Over thousands and millions of years, they coalesce into larger grains and pebbles. Those pebbles gather into rocks, and rocks into boulders, clumping silently under gravity's guidance. Eventually, some clumps grow large enough to draw others in, becoming infant protoplanets orbiting the newborn star. In time, tens of millions of years, this process may form a whole family of planets encircling that star. One day, there might be worlds with oceans and atmospheres in this very system, planets born of the same cloud that gave birth to the star. But that chapter lies far in the future. For now, all the ingredients are present. Dust rich with carbon and ice, gentle collisions building larger bodies, quietly unfolding around the young sun. Time in this nebula flows on a different scale. We float and watch as, over millions of years, the scene changes. The brightest, most massive stars come fully into their power, shining intensely and carving great cavities in the gas with their radiation and winds. The nebula's once sharp pillars and filaments are slowly eroded into delicate wisps. Eventually, much of the remaining gas disperses into surrounding space, revealing a newborn star cluster sparkling where it was once hidden. The cluster contains stars of many colors and sizes, hot blue giants alongside cooler golden suns, and numerous faint red dwarfs barely visible to us without aid. The variety is like a cosmic garden of different blossoms, each star shining with its own hue and brightness. Our gaze is drawn to one star in this cluster, perhaps similar in mass and colour to our own sun. It has emerged fully from the cloud and glows with a steady, comforting golden light. A young star, burning hydrogen quietly in its core. Around it, we can discern a slim circumstellar disk of dust and gas, the leftover material that may form planets. Within that disk, as we noted, dust grains are beginning to coalesce. If we leap forward in time, we would see that disk eventually fragment into planets, asteroids, and comets, the components of a new solar system. But that is a story for another time. For now, this star is a newborn, ready to embark on a long, stable adulthood. This star, and others like it, will spend a long time in the peaceful middle age of stellar life. The nebula that birthed them has largely dissipated. Some of its material now resides in the stars and their planets, and the rest has been blown into interstellar space. What remains is perhaps a faint haze around the cluster, or nothing at all to the naked eye. The cluster itself drifts slowly as it orbits the center of the galaxy, carrying its new stars on a grand 200 million year journey around the Milky Way for each circuit. We pause in the quiet of this region, marveling at how nature gently creates light from darkness. From cold, diffuse gas and dust, new suns have sparked into being and begun their long shine. It is a comforting thought. Even in the deepest reaches of space, light is continuously born. In this cosmic nursery, we feel the promise of renewal and the persistence of creation. Slowly, we begin to drift onward, leaving the stellar nursery behind. Our path now takes us through time as well as space, following the future of these stars we saw born. We watch the fates of the cluster's members unfold over eons. The massive blue-white star we noticed, the one so much larger than the rest, lives a life as brief as it is brilliant. Only a few million years after its birth, it has already exhausted the hydrogen fuel at its core. The star expands into a red supergiant, its outer layers swelling outwards, cooler and glowing a deep cherry red. This once blue-hot star has become an enormous, swollen giant, so large that, were it in our solar system, it might engulf the orbit of Mars. For a time, the red supergiant star shines with a ruddy light, as if signalling the end of its youth. Deep inside its core, heavier elements begin fusing in a last attempt to support the star's weight. Carbon, neon, oxygen, and silicon burn in nested shells, each stage shorter than the last, until iron accumulates in the core. Iron fusion yields no energy, so once the core fills with iron, the star's delicate balance is doomed. At last, the core can no longer withstand the crushing weight of the star's vast outer layers. In a fraction of a second, the core collapses, imploding under gravity with staggering force, and this triggers one of the most spectacular events in the universe: a supernova. Without warning, the dying star unleashes a titanic burst of energy. The core's collapse halts abruptly as atomic forces and quantum pressures stiffen the imploding material, and it rebounds, driving a shockwave upward. The star's outer layers are violently hurled into space. From our safe vantage point, we see a sudden flash where the red supergiant once glowed. It brightens to an unbearable brilliance. For a few weeks, this single star can outshine an entire galaxy. If we were watching from a respectful distance, we would witness a brilliant point of light blooming in the sky where a faint star used to be. It would initially shine bluish-white from its extreme heat, then gradually fade to golden, and finally crimson as the ejected gases expand and cool. Despite the unimaginable violence of the explosion, all is silent in the vacuum of space. A silent flash of tremendous light, followed by a ghostly, fading glow. As the supernova's glare subsides over months, it leaves behind a nebulous shell, a glowing cloud of debris expanding outward. What remains at the centre, where the star's heart once was? The core has been compressed to incredible density. In many such cases, the star's protons and electrons have been crushed together, forming a ball of neutrons only a few miles across. The entire stellar core is now a neutron star, an object more massive than our sun, yet only the size of a city. It is a bizarre, exotic, stellar corpse, extremely hot, extremely dense, often spinning rapidly from the leftover angular momentum of the star. We linger near this collapsed core, now a neutron star. A teaspoon of its material would weigh billions of tons. Its gravity is so intense that, if there were a surface to stand on, and one cannot truly stand on such an object, you would need to travel near the speed of light to escape its pull. Yet it is not a black hole. This core shines, emitting beams of radiation and streams of particles. If the neutron star is spinning, as most do, it may be emitting twin beams of electromagnetic energy from its magnetic poles. If those beams sweep across our line of sight, we would see flashes of light on each rotation, a cosmic lighthouse blinking on and off with astonishing regularity. In fact, such spinning neutron stars are known as pulsars. Some pulsars spin many times per second, ticking like ultra-precise cosmic clocks. Others spin more slowly, but all pulsars represent a star's core rotating in eerie stability, flashing its beacon of radiation into the cosmos. A cosmic event this powerful seldom goes unnoticed. Indeed, humanity has recorded such stellar deaths in history. In the year 1054 AD, astronomers in China, and likely elsewhere, noted a guest star that suddenly appeared and shone even in daylight for weeks before fading. That was a supernova in our own galaxy. Its expanding shell of debris is visible today as the Crab Nebula, and at its center lies a pulsar, the neutron star remnant, blinking about 30 times a second, like a cosmic heart still beating. More recently, in 1987, a massive star exploded in the neighboring Large Magellanic Cloud galaxy. For the first time, modern instruments captured not only the bright light of a supernova, but also a shower of invisible neutrinos, ghostly particles from the collapsing core. These instances remind us that the life cycles of stars occasionally intersect our human story, lighting the skies of long-ago stargazers and modern astronomers alike, linking us to the star's great drama. Not all dying massive stars leave behind neutron stars. If the star that exploded was even more massive, say 20 or 30 times the Sun's mass, the core's collapse might not be stopped at the neutron star stage. The core would continue to implode, crushing itself out of visible existence. In that case, a black hole is born, a gravitational well so deep that not even light can climb out from within a certain boundary. In our mind's eye, within the expanding supernova remnant, such a remnant would be invisible, a phantom of gravitation where the core used to be. We cannot see it directly, but we would know it by its influence. Gas, falling toward it, would whirl into a bright accretion disk, heating up and emitting X-rays before vanishing beyond the event horizon. Over time, however, as the ejected layers of the star drift farther out, the newborn black hole might simply sit quietly, with only a faint residual pull on the surrounding space, a silent tomb of a once brilliant star. This dramatic fate befalls only the most massive of stars. Meanwhile, the majority of stars in our cluster are far smaller and live far longer, steadier lives. Consider that sun-like star we followed earlier. Hundreds of millions of years, then billions of years pass. The star continues to shine calmly, fusing hydrogen into helium in its core. Eventually, after perhaps 10 billion years, it too begins to change. Having exhausted the hydrogen in its core, the core contracts and heats up, while the star's outer layers puff out. Our once medium star swells into a red giant, not as enormous as the red supergiant we saw, but still large enough to swallow any inner planets it may have had. Its surface cools and reddens even as its core grows hotter and denser. In its old age, it becomes a bloated, orange-red star, luminous but cooler on the surface. Any nearby worlds that existed would be scorched or enveloped as the star expands. Inside this red giant, the core has reached high temperatures and now begins fusing helium into carbon and oxygen. The star finds a brief new lease on life, shining anew from helium burning in the core. But this phase is unstable. The star undergoes thermal pulses, episodes where it ejects some of its outer envelope into space, Each pulse pushes more of the star's gas outward. The star is effectively shedding mass, creating a surrounding cloud of gas and dust. Finally comes the gentle end. The star cannot hold on to its outer layers any longer. A beautiful phenomenon unfolds. The star's outer envelope drifts off into space, expelled by those pulsations and winds, forming an expanding bubble or shell around the dying star. The core of the star, now exposed and fiercely hot, emits strong ultraviolet light that causes this cast-off envelope to glow. We witness the formation of a planetary nebula. This name is historical. Such nebulae looked round and planet-like in early telescopes, though they have nothing to do with planets. It is as if the star, in its final act, paints a luminous portrait of itself in the surrounding space. Imagine the sight: a dim central star, the tiny core, surrounded by an ever-growing shell of multicolored gas. Some planetary nebulae appear as perfect rings. For example, the Ring Nebula in Lyra is a glowing smoke ring in space. Others have intricate shapes like hourglasses or butterflies, sculpted by stellar winds and perhaps magnetic fields. Here, in our star's case, we might see a roughly spherical glow, with maybe clumps or asymmetries where the ejection wasn't uniform. The colours are lovely, often a teal or blue-green from ionized oxygen, reds from hydrogen and nitrogen. The nebula expands slowly, a few tens of kilometers per second, and as it grows, it reveals complex patterns, maybe multiple shells or faint rays. Some planetary nebulae that astronomers have captured show astonishing detail. The Cat's Eye Nebula, for instance, displays concentric shells and jets, forming a pattern like the iris of an eye. The Helix Nebula looks like a great cosmic eye, or coil. In our imagination, this nebula around our dying star might show similar beauty, a delicate bubble of glowing gas drifting into the darkness. At the center of the nebula, the core of the star remains behind. This core, no longer undergoing fusion, is extremely hot and small, about the size of Earth, and shines with a brilliant white or blue-white hue. It is a white dwarf, the final state of a star like the Sun. Composed mostly of carbon and oxygen, the ash of the star's nuclear burning, this stellar ember is incredibly dense. A teaspoon of white dwarf material would weigh tons on Earth. Yet, unlike a neutron star, a white dwarf is not so extreme that it warps space noticeably. It is a stable, albeit exotic, form of matter called degenerate matter. With no new source of energy, the white dwarf will gradually cool over billions of years, fading from white to yellow to red, and eventually becoming a dark, cold black dwarf. But the universe is not old enough for any white dwarfs to have cooled that far yet. Our white dwarf will remain as a warm, faintly glowing cinder for eons to come. In fact, scientists predict that in about 5 billion years, our own sun will undergo this same gentle death. It will swell into a red giant and then shed its layers, creating a lovely planetary nebula of its own. The sun's core will become a white dwarf that will slowly cool for trillions of years. Fortunately, this fate is unimaginably far in the future, so it doesn't concern us now. It's simply the quiet finale that awaits our star. Knowing that even the sun must eventually pass on in this peaceful way can be strangely comforting. It emphasizes the universality of these processes and the calm order underlying them. Like many sun-like stars, our sun will end its life not with a bang, but with a beautiful farewell, enriching space with its substance and then resting as a white dwarf. Some stars in the cluster are even smaller and cooler than our sun, little red dwarfs that glow dimly, with red light. These faint stars have so little mass and burn their fuel so slowly that they can live for hundreds of billions or even trillions of years, far longer than the current age of the universe. In fact, not a single red dwarf has had time to reach the end of its life in the entire history of the cosmos. These tiny stars will just continue to fuse hydrogen steadily, never swelling into giants, never exploding. Eventually, trillions of years from now, they too will run out of fuel and quietly fade, perhaps becoming a kind of cool, dark dwarf star. But that end is so distant that for all practical purposes, red dwarfs are nearly eternal from our viewpoint. They are the silent, enduring candles of the galaxy, destined to be the last stars shining after all others have died. Thus, within our cluster, different stars meet very different fates. The massive star died in a spectacular supernova, leaving behind either a neutron star blinking in the darkness, or perhaps a black hole, an invisible remnant marking the spot of its core. The sun-like star gently shed its outer layers, creating a glowing planetary nebula and leaving behind a white dwarf that will cool like a cosmic ember. The small red dwarfs continue to burn placidly, destined to outlive all their larger siblings and shine on in the quiet of the far future. The cluster is like a family whose members age at different rates. Some live fast and perish young. Others live slow and very, very long. Over time, the cluster itself disperses. Gravitational tugs from other passing stars and clouds gradually nudge members out of the cluster. After a few 100 million years, many of the stars born together are scattered around the galaxy, each going its own way. Some may remain loosely associated for longer, travelling as a moving group of siblings, but eventually most blend into the general starry background of the Milky Way. Yet they carry with them the products of their lives and deaths. The massive star's supernova seeded space with heavy elements like iron and gold. The medium star's winds added carbon and nitrogen to the galaxy. Even the gentle red dwarfs, through flares and stellar winds over time, contribute a bit. We realize that every generation of stars enriches the galaxy's reservoir of gas. The newborn stars we saw were already formed from material enriched by previous stars that lived and died before them. Our sun, for instance, contains heavier elements, carbon, oxygen, iron, and so on, that must have come from supernovae and dying red giants in our galactic neighbourhood before the sun was born. Without those earlier stars, Earth would have no metal in its rocks, no oxygen for us to breathe, no carbon in our bodies. All the elements heavier than helium, the calcium in our bones, the iron in our blood, the silicon in sand, were forged in stellar furnaces and spread through space by stellar deaths. In a very literal sense, we are made of stardust. It's humbling and reassuring at once. In the cosmos, nothing is truly lost. It only changes form and reappears in new ways. The death of stars seeds the birth of new stars and planets. What seems like an end is also a beginning in the grand scheme. It is a continuous grand cycle that has been going on for billions upon billions of years. Recognizing this cosmic recycling brings a peaceful sense of order. Creation and destruction are partners in an endless, beautiful dance. In fact, we can imagine the Milky Way itself as a living organism on a vast scale. It has its own kind of breathing. When stars form, the galaxy inhales gas into dense new suns. When stars die and return their matter to space, the galaxy exhales enriched gas back into the void. The spiral arms are like graceful arms of a giant, sweeping material around. The magnetic fields threading the galaxy are its invisible nerves, and the constant flux of cosmic rays could be thought of as its bloodstream carrying energy and information. The galactic center might be its heart, calm now, beating slowly with minimal activity, but capable of stronger pulses when provoked by infalling matter. Over eons, the galaxy maintains a dynamic balance, drawing in matter, transforming it in stars, and releasing it again, not unlike an ecosystem cycling nutrients, or a living body renewing its cells. Seeing our galaxy this way, almost as something alive with long, slow rhythms, highlights how interconnected every part of it is. Each star's life and death, each drifting cloud, each wisp of magnetism and flash of cosmic ray plays a role in the Milky Way's ongoing story and steady heartbeat. Now our journey carries us further outward into the wider structure of the Milky Way. Leaving the bright tumult of the starry disk, we drift gently above the galactic plane. Slowly, we begin to rise out of the crowded disk, as if riding a cosmic elevator. The bright band of the Milky Way narrows below us. Stars thin out around us as we ascend into the galactic halo. The clamour of the densely packed plane gives way to a vast, serene expanse. We pass an occasional solitary star, or a small cluster on our way up. Looking down, the Milky Way's disk stretches out like a luminous, silver-blue pancake, a glowing continent of stars against the black of space. Looking up and away from the disk, we see mostly darkness, dotted with a few nearby galaxies like distant island lights across a cosmic sea. Up above the plane now, we pause to take in the view. Below, the great disk of our galaxy is visible in profile, a thin, glowing line with a brighter bulge in the middle. It is breathtaking and tranquil. In this lofty perch, we can see the structure of the Milky Way more clearly. If we could fly even farther out and look back from afar, we'd see our home galaxy as a majestic spiral. Its spiral arms are coiled around a bright central core, sparkling with hundreds of billions of stars. Vast clouds of glowing nebulae trace the arms, and dark ribbons of dust wind between them, forming the dim lanes we see as the great rift from Earth. A diffuse, spherical halo of ancient star clusters surrounds the disk, like a gossamer aura. The Milky Way would indeed appear as a magnificent pinwheel of starlight suspended in space, a true island universe. But even without venturing that far, our perch above the galactic plane already gives us a sense of the Milky Way's graceful form and immense scale. In the faint outskirts of the halo, we notice we are not entirely alone. Scattered around the Milky Way are smaller companions, satellite galaxies orbiting the big galaxy, like moons around a planet. The most prominent are the large and small Magellanic Clouds, visible from Earth's southern hemisphere as misty patches of light. Turning our gaze to them, off to the side of the Milky Way's disk, we see the large Magellanic Cloud, LMC, hanging like a detached piece of the Milky Way, an irregular little galaxy of its own. It appears as a scattered, cloudy collection of stars. Within it, bright nebulas and star clusters shine. It may be small, but it is lively. The large Magellanic Cloud contains millions of stars and active star-forming regions. In fact, one of the brightest star-forming regions in our local group of galaxies lies in this dwarf galaxy. The Tarantula Nebula, a colossal stellar nursery teeming with massive young stars. Not far from the LMC is its sibling, the Small Magellanic Cloud, SMC, a fainter, smaller smudge of light. The two clouds are irregular and not as structured as our Milky Way, but they are rich in their own wonders. Let us imagine venturing into that tarantula nebula in the LMC. As we approach, we see a vast web of gas and dust stretching hundreds of light years across, glowing an intense pinkish red. The nebula earned its name because its bright filaments resemble the legs of a giant spider sprawling among the stars. Inside, dozens of extremely massive newborn stars blaze like a cluster of tiny suns on steroids, flooding the nebula with fierce ultraviolet light. The surrounding gas is ionized and hot, shining proudly. We drift amid a flurry of star formation even more vigorous than in the Orion Nebula at home. The colors are vivid. Deep rosy hues from hydrogen, eddies of purple-blue from ionized oxygen. Great pillars and ridges of denser gas crisscross the nebula, carved by the torrents of radiation. This is one of the most energetic starbirth regions in the entire local group of galaxies. In 1987, a star on the edge of this nebula ended its life in a spectacular supernova, an event observed from Earth as the famous SN 1987A. We can still see its faint remnant, a delicate ring of glowing gas expanding within the Tarantula Nebula, marking where that star exploded. The Tarantula Nebula is like our Orion Nebula, magnified hundreds of times in size and intensity, a true furnace of creation. Even our small neighbor galaxy can host such cosmic marvels. After marveling at this turbulent, yet wondrous stellar womb, we drift gently back toward the Milky Way, leaving the Tarantula's domain behind. The knowledge that other galaxies, too, have their nurseries and celestial dramas reminds us that the processes we've observed are universal. Star birth and death, cosmic cycles and renewal. They happen not just here, but everywhere we look. The Magellanic Clouds do not simply orbit idly, they interact with our Milky Way. The gravity of our galaxy tugs at them, and in return, they tug on our galaxy's stars and gas, causing subtle ripples in the Milky Way's disk. A stream of gas, drawn out by these interactions, stretches from the clouds toward our galaxy. The Magellanic Stream, a bridge of hydrogen that is slowly raining down material into the Milky Way's halo. Over billions of years, the Magellanic Clouds themselves may be absorbed, merging with our galaxy and adding their stars to the Milky Way's population. Yet, this process is slow and graceful on human timescales. From our perspective tonight, the clouds simply circle peacefully. If you were in the southern hemisphere on a dark, clear night, you could see these two faint cloudlets hanging near the Milky Way, much as our ancestors like Magellan, after whom they're named, saw them during their voyages. Indigenous peoples of the southern hemisphere had their own names and stories for these clouds, long before. They were not mysteries to them, but familiar sights in their sky lore. The Magellanic Clouds are not the only companions of the Milky Way. In fact, there are dozens of known dwarf galaxies orbiting our own. Some, like the Sagittarius dwarf galaxy, are currently being cannibalized, stretched out and absorbed by the Milky Way's gravity. The Milky Way is tearing the Sagittarius dwarf apart, and its stars have formed a huge, looping stream encircling our galaxy. Those stars, once part of a separate galaxy, are now gradually becoming part of the Milky Way, wrapping around it in ghostly filaments. Other satellites, with poetic names like Draco, Sculptor, Carina, and Fornax, are faint, spheroidal puffs of old stars hovering in the halo. They are difficult to see even with large telescopes, but they are there, each a tiny sibling galaxy in orbit. These companions all move under the sway of the Milky Way's gravity, tracing ellipses and loops. Together with our galaxy, they form a small galaxy family, bound within an enormous halo of invisible dark matter that envelops the Milky Way and its satellites like an unseen scaffold. The dance of these minor galaxies has been going on since the Milky Way's youth. In fact, our big galaxy likely built itself up by merging with many smaller protogalaxies early on. The evidence is etched in the stars. Our halo contains streams and clumps of stars with distinct properties, which are the remnants of long-ago galaxy mergers. The Milky Way is like a majestic tree that grew from many seeds. Each seed a smaller galaxy that was incorporated. The Magellanic Clouds and Sagittarius Dwarf are simply the latest partners in this slow cosmic dance. And the dance will continue on an even grander scale. Our Milky Way itself is on a slow collision course with the great Andromeda Galaxy, our nearest spiral neighbour. In about 4 billion years, the two giant galaxies will begin to merge. This future encounter will be a majestic and slow-motion event, not a sudden, catastrophic crash, as one might imagine, for the stars within each galaxy are so far apart that direct stellar collisions will be extremely rare. Instead, the galaxies will pass through one another, their mutual gravity pulling out long tidal streams of stars and gas. Over the course of several billion years, the Milky Way and Andromeda will dance around each other, their shapes warping and intermingling. Their gas clouds will collide and compress, likely igniting waves of new star formation, a flurry of baby stars to mark the occasion. From some planet in the distant future, the night sky during the merger would be filled with awe-inspiring sights. Perhaps great bands of stars from Andromeda sweeping across the heavens, nebulae flaring up in brilliant regions of new stars. Eventually, the two galaxies will settle as one larger, blended galaxy. Probably an elliptical galaxy, a gigantic ball of stars, where once there were two spirals. But this dramatic destiny lies far, far in the future. By the time the Milky Way and Andromeda fully merge, our Sun will have evolved into a red giant or white dwarf, and the Earth as we know it may no longer exist. It's a cosmic event on a time scale almost beyond human comprehension. For now, Andromeda is merely a faint, fuzzy patch in Earth's night sky, visible in the constellation Andromeda on a clear, dark night. It silently edges closer at about 110 kilometers per second. It's hard to fathom that this gentle smudge of light is an entire galaxy hurtling toward us. Eventually, it will mingle its stars with ours, continuing the grand story of galaxies growing through union. But tonight, under cosmic midnight, that ongoing journey brings no fear. It underscores the immense timescales and resilience of the universe. As we reflect on all these scales, from newborn stars to merging galaxies, a clear picture emerges of a cosmos in motion, yet balanced and cyclical. We have witnessed how, from darkness, light is born, how even the brightest star eventually returns its substance to the dark, making new light possible. We have seen that invisible forces, like gravity and magnetism, quietly shape the destinies of stars and galaxies. We watched smaller galaxies dance with and become part of larger ones. And we observed how we, tiny conscious beings on a planet, are connected to all of this, made of the dust of stars and moved by the beauty of the night sky. Our voyage through galactic midnight has carried us through these many wonders, and it also serves to bring a deep calm. We have roamed among glowing nebulae and dense star clusters, witnessed the brilliant death of stars and the silent drifting of cosmic dust, and glided alongside galactic companions in their slow dance, all under the quiet, eternal night of space. We have also seen how human history and imagination are intertwined with the cosmos, how, for ages, people everywhere have looked up and found guidance, stories, and comfort in that milky band of light. Now, returning gently to our earthly vantage point, imagine yourself lying back on a soft hillside on a clear, dark night. The air around you is still and cool. Perhaps you feel the gentle cushion of grass beneath you and hear it whisper softly as a mild breeze passes. There is a faint scent of earth and wildflowers on the air. Silhouettes of trees stand quietly against the horizon, and a cricket sings somewhere nearby. The world is calm and hushed. Above you, the vault of the sky is jet black and filled with stars, and stretching clear across that sky is the Milky Way, our galaxy seen from within. It arches from horizon to horizon like a glowing river of countless diamonds. Toward the direction of the galactic center, somewhere above the southern horizon if you're in the northern hemisphere's summer, or high overhead in the tropics, the Milky Way thickens into an oval bulge of light crossed by dark rifts. Those dark patches are vast clouds of interstellar dust blocking the more distant stars, creating the appearance of a split in the starry band, what some call the Great Rift. Scanning across the sky, not far from this shimmering band, you might notice a small cluster of blue-white stars wrapped in a faint haze, the Pleiades star cluster. These seven sisters are young stars born from a nebula not long ago, in cosmic terms, and still travelling together as siblings. The delicate mist around them is the remaining dust from their birth. The Pleiades add their own subtle sparkle to the night and remind us that the creative processes of the galaxy continue even in our neighbourhood. Under such a sky, you might feel both tiny and tremendously connected. The Milky Way's light is so pure and strong on a dark, moonless night that it can cast a faint shadow on the ground. It glows with a soft, diffuse radiance that can entrance the eyes. To ancient peoples with dark skies, this band of light was a striking presence every clear night, and they wove countless legends about it. Even today, if you escape the city lights and lie under this river of stars, you can sense why it inspired wonder. It spans the dome of the sky above you, a glowing highway linking horizon to horizon, constant and reassuring. All around the world, people saw this milky band and gave it names rich with imagery. To the ancient Greeks, it was Galaxius, the milky circle, born from the milk of a goddess. Hera's milk spilling across the heavens, in their myth. To the Romans, it was Via Lactea, the road of milk. We still use that name, Milky Way, carrying a bit of that myth in our modern term. To the Chinese, it was the Silver River of Heaven, a celestial river separating two lovers, the weaving maiden and the cowherd, placed apart by a stern goddess. They meet just once a year, when a bridge of magpies forms across the Silver River, so they can reunite for a single joyous day. On the 7th night of the 7th lunar month, Kishi, people celebrated the meeting of those stars, Vega and Altair, and the spanning of the Milky Way. One can almost see it, the broad river of stars across the sky, and two bright stars facing each other across the divide, longing to meet. In India, The Milky Way was revered as Akash Ganga, the Ganges of the sky, a sacred river of light reflecting the holy river on earth. In Egypt, it was perhaps seen as a heavenly Nile, or as the milk of a divine cow, the sky goddess in bovine form, nourishing the world with her stars. In Ireland, the Milky Way was often called Bealach na Bó Finne, the way of the white cow, imagining the misty band as a great white cow travelling the heavens, or as her milk spilled across the night. This image parallels the Greek and Egyptian notions and shows up in Celtic lore as well, another echo of the idea of a celestial cow or her milk giving life to the night sky. In Hungarian legend, it was thought of as Hadok Utja, the road of warriors, a shimmering path taken by ancient warriors, or perhaps the sparks from their horseshoes. Many northern cultures, like the Finns and Estonians, saw it as the pathway of birds. They observed migrating birds using the stars to navigate south, and fancied that the birds followed this shining band in the sky to find their distant home. A Cherokee tale from North America tells of a dog who stole some cornmeal and ran off into the sky. As he fled, he spilled the cornmeal from his mouth, leaving a trail of pale dust across the darkness. Thus, the Cherokee called the Milky Way where the dog ran. One can almost picture that mischievous dog bounding across the night heavens, a cloud of glimmering cornmeal grains scattering behind him to form the Milky Way. In the folklore of the San people of southern Africa, they say that in the beginning the night sky was completely black. The world was dark, and people could not see. A young girl, feeling lonely and wanting to visit others in the dark, scooped up a handful of glowing embers from her campfire. She flung the embers into the sky with all her might. Up they flew, the red coals scattering high above. As they rose, they turned into sparkling stars. Those embers stuck on the black canvas of the sky and became the soft band of stars we now see as the Milky Way. Thanks to her action, the night was no longer lightless. A path of faint starlight now stretched across the heavens to guide and comfort travellers. The San recall that brave girl whenever they see the Milky Way, knowing that her embers still glow up there, ensuring no one need be lost in the dark. These are just a few of the countless stories human beings have spun about the Milky Way. Every culture saw something familiar or meaningful in it. A river, a road, a bridge of souls, spilled milk, flying sparks, a divine animal, a path to heaven. Gazing up at the Milky Way, people felt awe, but also a strange intimacy, as if this glittering band was placed in the sky just for them, to tell them something important. It connected the earth to the cosmos, the living to the divine. Even now, knowing what we know scientifically, the Milky Way evokes the same feelings. Understanding that it is a multitude of stars does not rob it of magic. If anything, it deepens our sense of wonder. When we realize that each faint speck in that band is a sun, possibly with planets and perhaps life, the Milky Way becomes not just a pretty backdrop, but a vast community of worlds. On a dark night, as your eyes adapt, you might notice that the Milky Way has a subtle glow and structure. Its light is the pooled glow of billions of distant stars, too faint to see individually. As you continue to gaze, you discern that the band isn't uniform. It has brighter sections, curious dark splits, and an overall granular texture. The brighter sections are where our line of sight passes through spiral arms or the central bulge. with dense star clouds adding their light. The dark splits, like the Great Rift, are caused by interstellar dust blocking the starlight. The same dust that, up close, forms beautiful nebulae, and in time makes new stars and planets. All of this is visible to your unaided eye from a good location, and it's no wonder that ancient stargazers, without modern light pollution, studied these patterns and incorporated them into their star lore. Under this resplendent arch, it's easy to feel a profound sense of connection. That band of light is the cross-section of our galaxy. It is the collective light of our stellar neighborhood. Somewhere in that vast arch, our sun is one of those myriad points. In fact, from our viewpoint, we are about 2/3 out from the center, looking in and around. When you behold the Milky Way, you are essentially looking at the forest of stars that our sun belongs to. We are inside that grand structure, part of it. The realization can be both humbling and comforting. We are home. We belong here in this galaxy, as much as the stars themselves do. As you lie there, let yourself absorb the grandeur and tranquility of the night. The Milky Way's mysteries, now somewhat revealed to us through our journey, make it all the more meaningful. You know that glow is billions of distant suns. You know dark clouds drift among those stars, birthing new ones. You know supernova remnants and clusters are out there, even if your eyes only perceive a milky haze. And you know that the ingredients of your own body were forged out there in those stars over cosmic time. We are children of the Milky Way, made of its matter, living on a planet orbiting one of its stars, and looking back at it with wonder. In a sense, when we gaze at the Milky Way, the galaxy is observing itself through our eyes. We, conscious beings made of star stuff, can contemplate the very galaxy that gave us birth. All these insights, however, do not crowd the mind. Instead, they settle in like a deep peace. It feels as if the universe has an order, a rhythm, a story in which we have a place. That feeling lets ordinary worries fall away. Under the infinite sky, day-to-day concerns shrink and dissolve. In the face of cosmic time and space, our hearts find stillness. So now, simply breathe in this stillness. Take a slow, deep breath. Inhale the cool night air, as though you are drawing in the serenity of the entire cosmos. Let that peaceful air fill your lungs and your being. Then exhale, just as slowly, breathing out any tension. With each breath, you sink deeper into comfort. Breathe in the calm of starlight. Breathe out and let go of any lingering worry. Match your breath to the gentle rhythm of the night. You might imagine that as you inhale, you are collecting the tranquility of all those distant stars, and as you exhale, you release your stress into the universe to be carried away on a solar wind. Each breath makes you feel more connected to the vast, quiet cosmos around you. Your body is relaxing more and more. If you notice any tightness in your muscles, imagine it simply melting away into the ground below you, or evaporating into the cool starlight above. Any stray thoughts that come to mind, acknowledge them gently, and then let them drift off, like a small cloud crossing an otherwise clear sky. They fade into the darkness and vanish, leaving your mind clear and restful. Now you are floating in a state of ease, your breathing slow and natural, your heart steady, calm and quiet, like a tranquil star in a quiet corner of the sky. In this peaceful state, you might almost hear a subtle music, the imagined harmony of the spheres that philosophers once spoke of. The ancient Greeks believed the stars and planets made music as they moved, a celestial harmony too pure for human ears. Of course, the stars move in silence, but one can still fancy a soft, cosmic lullaby playing. Each star could be a note in a grand nocturne. Together, the billions of stars of the Milky Way create a symphony of light. Perhaps your mind's ear can pick up a faint astral melody, not a real sound, but a feeling of sublime order and peace, as if the universe is humming a gentle tune. In this profound quiet, you feel safe and cradled by something much larger than yourself. The night is vast, but it is welcoming, not threatening. The stars are distant, but their light, many-coloured and ancient, is kindly. The earth beneath you holds you firmly, and above, the cosmos arches in all its grandeur. You realise that this moment is all you need to be in. The past and future recede. Right now, you are simply a peaceful observer in a peaceful universe, resting under the glow of the Milky Way. If you listen closely with your imagination, you might hear the faint pulse of a faraway pulsar, a steady, reassuring beat in the distance, like the universe's heartbeat, syncing with your own slow heartbeat. In the same way, your breaths align with the gentle sigh of the night, in and out, nice and slow. All the mysteries we explored, star birth, star death, cosmic rays, magnetic fields, dancing galaxies, and ancient myths, have brought us not only knowledge, but also a sense of belonging and peace. The galaxy is not a cold, foreign place. It is our broader home. Its doors are open above us every night. Feel the weight of your body gently supported by the ground or your bed. Feel how you, too, are under the influence of the same gravity that organizes the stars. The earth holds you, just as the sun holds Earth in orbit, just as the galaxy holds the sun. You are anchored, secure. As the stars keep their courses above, so do you remain steady and at ease. Now, you have permission to let go completely and drift into sleep. The universe will keep watch. The stars will continue to shine, and the planets will continue to turn in their silent, orderly way. You can rest, knowing that dawn is distant and all is well in this moment. Above, the Milky Way arches like a guardian, an old friend watching over the night. If you haven't already, allow your eyes to gently close. Imagine that bright river of stars still above you, now in your mind's eye. Its soft glow is imprinted in your memory. You carry that light within you. Feel how your breath has become very soft and slow, your body heavy and relaxed. There is nowhere else to go, nothing else to do, just to be here, safe under the stars. If you find any tension, imagine it melting away into the ground or evaporating into the starlight above. Any remaining thoughts float away like little clouds, leaving your mind clear and quiet. Your entire being is at peace. Now, in this silence, you are drifting in the gentle current of galactic midnight. The stars around you are like a soothing blanket, their faint twinkle a lullaby of light. The cool night breeze, or the soft hum of your room, is the only sound, like the whisper of the galaxy saying, "All is well, you can rest now." In the distance of your mind's ear, you might almost hear the faint music of creation, the choir of newfound stars in nebulae, the bass of distant supernovae echoing through the ages, the strings of magnetic filaments gently resonating, all blended into a single gentle hum. It is the universe's lullaby, and it is just for you at this moment. You are so relaxed now. Your breathing is slow and effortless. Your arms and legs feel pleasantly heavy and warm. Your mind is unburdened, content. You are drifting in the darkness between stars, but you are not lost. You are part of that starlight and darkness both, cradled by the galaxy itself. The Milky Way's soft glow is like a nightlight left on by the cosmos for you. Feel how natural it is to let your consciousness drift like this. Our very atoms have travelled through stars and galaxies, and now our thoughts travel through the cosmos we've imagined. You are gently floating down like a feather released, descending into the realm of sleep. The universe holds you as you descend, just as surely as it holds the stars in their places. Each moment you fall more deeply asleep. You might dream of gliding among stars, or perhaps of walking along a luminous silver river at night, or simply enjoy a deep, dreamless sleep as vast and quiet as interstellar space. Whatever comes, you are safe and held. The stars will be here when you wake, and tomorrow night and the next, constant companions, even if hidden by daylight. You can always return to this feeling of calm by remembering the grand stillness of the night sky. For now, let yourself go completely. There is nothing more to do but surrender to the gentle pull of sleep. Like a spacecraft coasting with engines off, you are carried forward by momentum now, the momentum of relaxation that will carry you into sweet rest. As you gently transition into sleep, imagine the Milky Way above as a shimmering bridge, perhaps like the one in the old Chinese story, made of countless magpies, connecting the conscious world to the dream world. Cross that bridge now, lightly and easily, to the land of dreams. Your eyelids are heavy, your body is loose and limp. A deep tranquility fills you from head to toe. You are drifting into a deep and restful sleep. All around, the galaxy watches over you. The billions of stars twinkle like distant guardians. The same cosmic forces that keep the stars on their paths ensure that you are secure here on Earth, breathing softly under your blankets. Tonight, you are truly at peace. You are as quiet and content as a sleeping star.
Sleep now, dear traveller. Let the mysteries of galactic midnight lull you into the sweetest of slumbers. You are home in the universe, and all is well.
Good night, beneath the Milky Way's eternal light.